In episode 49 of the CySec 101 training series, we're going to go through the basics of Kappa, which is a very unique tool that we can use to identify what executable files do. So it basically looks at the functionalities of an executable to tell you what it does without you having to execute the file. And this is a very important tool. It is in our defensive security tooling module, which is a part of the cybersecurity 101 pathway of TryHackMe. And inside of this video, we're going to obviously go through the introduction of Kappa. We're going to go over the overview of how it actually works. We're going to dissect the results. So there's going to be multiple parts to this. We're going to dissect the results in part 1, the general info MITRE attack framework. So I don't know if you've heard of that before, but we're going to be talking about that, and it's a good idea for you to know about it. And then the MAEC or make, I think that's MAEC or make, I think it's make. And then we're going to look at malware behavior catalog, and then we're going to look at namespaces, capability, and of course more information and more fun. And there's going to be a virtual machine that we're going to launch throughout this whole process. And this is a subscriber only room, so it does require that you need to have a paid subscription to TryHackMe. But if you just download Kappa on your own computer, you could essentially run along with all of these exercises with me. And most likely, if you're watching this video, you probably have access to TryHackMe, so you would just follow along with the TryHackMe room. So whether or not you have access to the TryHackMe platform is kind of irrelevant, because you can always just download the tool and use the tool directly yourself. So that is it for the overview of this particular video. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server as well as early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, bug bounties, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhacks, hackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Kappa basics room. So the premise for this room and for the Kappa tool in general is about one of the biggest challenges that we actually face as security engineers and analysts. And this is when we have to potentially or analyze software that might be potentially malicious. And if you analyze it by launching it, you would expose your machine or your environment to being compromised, and it can cause you a big amount of issues. If you don't have access to a sandbox, it makes it even more difficult, or some kind of isolated environment where you can actually test everything as much as you want. So usually, if you do this with some kind of an executable file, in an ideal case, you would be able to do it inside of a sandbox environment or an isolated computer or isolated virtual machine. But what if you don't have that, right? What if you don't have access to something like that? So generally speaking, there are 2 types of analysis that you could do. One of them is dynamic analysis that actually happens when you launch the software, when you launch the executable. And the other one is static analysis. And what we're going to be focusing on in this particular video is the concept of static analysis using the tool Kappa. Now, Kappa stands for Common Analysis Platform for Artifacts. So it's an analysis platform, and we use it to analyze artifacts. And it's a tool that's developed by the FireEye Mandiant team, and it's designed to identify the capabilities present in executable files like a portable executable, which is PE or ELF binaries or .NET modules, shellcode, and even sandbox reports. So it does this by analyzing the file and applying a set of rules that describe common behaviors. And it allows it to determine what the program is actually capable of doing, like if it's going to establish a network communication, if it's going to manipulate files, if it's going to inject something into your processes, and so many more things. So whatever the executable is designed to do, essentially Kappa can help you identify that without you having to run it. What Kappa does is that it encapsulates years of reverse engineering knowledge in an automated tool, which makes it accessible even to people who are not experts in reverse engineering, which I'm not, right? So I can't look at the source code of a really complex application and be like, oh, okay, this is where the problem is inside of the source code. I can't do that. I'm pretty decent with Python. I can write automations in Python, but that's kind of it, right? So if I looked at an application source code, I wouldn't be able to tell you if there are vulnerabilities inside of that source code. And that's what this specific tool helps people like me do, right? So if you aren't good at reverse engineering code and trying to find where vulnerabilities are or exploits have been injected into the code, this is why Kappa can actually be very helpful for you. So it's very useful for analysts, security professionals, which allows us to quickly understand potentially malicious software functionality without actually reverse engineering the code. So that's the whole idea here. It's useful in malware analysis and threat hunting, where understanding a binary's capabilities is crucial for incident response and defensive measures. So we're going to explore what Kappa is. We're going to learn how to use it, understand the common fields and results that are rendered by it, and leverage it to identify the program's potential activity. And the prerequisites for this would be the MITRE ATT&CK framework. And this is actually a really powerful framework in general for you to have access to. I have done a video on this. I've actually done a couple of videos on the MITRE ATT&CK framework. So if you have not checked it out, I highly recommend you check it out. You can do just a search on our channel for MITRE and you'll be able to find the couple of videos that are available. You can also just go to Google and type in MITRE ATT&CK, and you do it with the ampersand, right? So I think even if you did like a attack with an A right here, it'll still work, show up for you. And this is what literally the first result is. And when you click on it, it takes you to the attack matrix. And these are essentially all of the techniques and tactics that specific attack not, oh my god, my brain just had a fart. So these are the techniques, tactics, and procedures that advanced threat groups have done. So there we go, that's what it is. So we have advanced threat groups, we have hackers, we have state-sponsored attackers, all of these different malicious actors who have attacked different organizations, governments. All of the data that's been gathered from all of those activities has been stored inside of the MITRE ATT&CK framework, which is a very, very powerful resource for anybody who wants to get access to threat hunting. So for every single one of these categories right here, so let's say initial access, you have 10 techniques under initial access. You click on any of them and it'll take you into that technique and it'll give you a bunch of examples of the procedures, meaning the various times that it was implemented. It'll give you examples for mitigations. It'll give you detection mechanisms and of course all of the reference points. And then what's interesting with this is that, you know, you can click on any of these. So let's say I click on Agrius and it'll take me into the Agrius group profile. And so this is an Iranian threat actor that's active since 2020, notable for a series of ransomware and wiper operations in the Middle East with an emphasis on Israeli targets. Public reporting has linked Agrius to Iran's Ministry of Intelligence and Security. So, you know, it just so happens that the first thing that I click on has to do with my home country. So I have no affiliation with these guys, just in case you want to get smart about it and go crazy in the comment section. But it shows you all of the details of everything that Agrius has actually done and the types of attacks that they've done, the types of software that they've used, so on and so forth. So the MITRE ATT&CK framework, the MITRE ATT&CK matrix, the MITRE ATT&CK website is extremely useful, and you can get a lot of very powerful threat intelligence from this specific resource. And this should be something that you visit regularly just for your homework, for individual research if you want to do it. If you read something about some kind of attack group, advanced persistent threat group, any of these things, if you want to get more information about it, more likely you can find it on the MITRE ATT&CK website. So that is that little tidbit on MITRE ATT&CK. And then there's a bunch of different videos on MITRE ATT&CK as well, where we really dive deep into how to actually use their website to gather threat intelligence. So I've already launched the virtual machine. It's actually up and running. We're going to be using it in a little bit. If you have access to OpenVPN and you want a remote desktop into the virtual machine, you can do that. This will be the username and password, but by the time that you watch this, this IP address is going to be changed. So whenever you want to connect to this machine, if you have an account with TryHackMe, your IP address would be different to actually remote desktop into it. And inside the VM, we have installed a Kappa software, so it's already there. So we can learn how to run it and experiment further with the different command parameters. It takes a long time to finish using the attached VM, so we have pre-process the reports such as the following. So we actually have these reports that are generated for us. They'll give us some examples of how to run the commands and the parameters that we could use, but to save time, they've already generated reports for us that we're going to use to answer the questions inside of this exercise. They are inside of this specific directory, and that is pretty much it. So that being said, let's now actually look at the tool itself. So the overview of how Kappa works. So to run Kappa, you basically need to open PowerShell. Obviously, you want to make sure that you're in the right directory because you need access to the executable file. If not, you need to give it the full path of where this executable is actually located. Once you're inside of this directory, you can then just run kappa.exe, and that's basically it, right? So the example that we're going to be using is the cryptbot.binary. So the results of this file will be discussed throughout the succeeding task, meaning the very next task. After running the command, we wait for the result, which takes several minutes. We don't intend this to finish, but rather to let you get a feel for running the tool. So we suggest that you continue the task while Kappa is running to stop the process from running. So there are alternative ways to proceed with the analysis of the results, and this is one way. They have blocked this out because I'm guessing we are going to be trying to do it. Oh no, that's the success bar. So that's the completion bar. So this is what it looks like when it's completed. It went from 0 to 100%. And that's it, right? So you give it the executable, you use the executable, and then you give it the location to the binary file that you want to examine, and it'll start analyzing that program. We have the dash H menu, which is usually what is available to get to the help menu. Then you have V for verbose, and then VV, which is very verbose, and that has to do with how much detail is displayed onto the screen for you. As it's developing, right, as it's running, it'll print stuff onto the screen. Then it'll obviously give you the same type of verbosity, the same type of extra detail when it creates its final report for you. So this is what it would look like when it's finished. So we actually have the binary analysis. So you have the various MD sums that are available for it. So the MD5, SHA-1, SHA-256, these are the checksums, the hash values that are associated with this specific binary. The analysis was static. The OS is Windows. Format is PE because it's a executable file. This is the architecture, and then this is the path of where it's actually located. Then we have the attack technique and the attack technique. And these are from the MITRE attack framework, as we saw already. And there's a lot of different tactics and techniques that are available. And then you have the MAEC category and the value for it. So it falls under malware, and it's a launcher type of category or launcher type of binary. Then there is the objective and the objective behavior. So anti-behavioral analysis, so the virtual machine detection, and then anti-static analysis, so executable code obfuscation, communication, data, defense evasion, all of these various details come out of it. So you can see it's a very, very detailed output that we get from our lovely Kappa tool, which is amazing. So this is where the capabilities kind of come in, right? So it actually lists the various capabilities of this binary. So referencing the anti-virtual machine strings, and then targeting the VMware, targeting VirtualBox, contains obfuscated stack strings. So this is actually, I believe it's even used to work inside of virtual machines or against virtual machines, from what it kind of says. Contain obfuscated stackings or stack strings, reference HTTP user agent string, check the HTTP status code. This is pretty crazy. So, I mean, I'm not going to go read this line by line because it would be a lot of reading to do, but you can essentially pause the video and just read through these things if you're really interested. So since we know that the processing time takes several minutes, we have pre-processed this to a file, which is the cryptbot text, which is going to be the report basically that we see right here. That entire report is exported for us inside of this text file, which is again inside of the Kappa directory. At the same time, this has been attached to this task. By clicking download task files, we can also get this on our desktop, on our machine that for me, for example, on my computer, I can download it. I'm not going to do that because it's already available in the virtual machine and I'm running the virtual machine. So I'm just going to use the report that's inside of the virtual machine. So we can open another PowerShell terminal and then use the command get content cryptbot.txt, or you could just double click it since we're inside of a Windows machine, and then it would actually load the content for you, and it'll give you the same output that we saw from the terminal essentially. And that's basically it. So what command line option would you use if you need to check what other parameters you can use, which is basically the help command, right? So we would do -H for this. What command line options are used to find detailed information on the malware? Use the shortest form, so that would be -V for verbose. What command line option do you use to find very verbose? And it's kind of in the question, which is the VV. What PowerShell command would you use to read the content of a file? And this is a commandlet that's inside of PowerShell to actually read the contents of a file, which is get content. And that's pretty much it, right? So it's very simple to actually run this thing. You basically just use the name of the software. It's either Kappa or kappa.exe, whichever one you want to do, as long as you're in the location that actually stores that executable file for Kappa. And then right after that, you give it the path of the binary or the executable that you're analyzing. And in this case, when you see // that means it's in its current directory. So it's actually inside of this directory. So let's go look at it real quick because I want to show you this. Let me zoom out and I'll show you what it looks like inside of the actual virtual machine that we have. So we're going to do show split view. That's our virtual machine that has loaded for us. And on the desktop, we should have something called Kappa, and right there it is. So if I open that, I can see that inside of it, I have the Kappa cryptbot binary and the text, and then VVJSON and VVText. So these are all of the reports that we have over here that are available for us. The executable that we need to look for is inside of it's actually inside of the administrator's desktop. So the desktop Kappa file, which is over here somewhere. So I think it's literally this piece right here. So it's this actual Kappa location. So the reason why they said go inside of the directory is because the binary is inside of the directory. So if it's not inside of the directory, or if you are not inside of the directory, instead of doing just the name of the executable for Kappa, or just instead of calling on the Kappa tool and then giving it this location for the binary that you want to analyze, you would have to give it the full path. So in this case, it would look like this, right? So I'm just going to open it just so you can see. Essentially, if I don't go inside of the directory that holds this binary, what I would need to do is I would need to actually do, C, and then is PowerShell even loaded, bro? This machine is slow, clearly. So this is what you would need to do. Basically, you would do from any location, right? You can run the Kappa executable from any location inside the computer, but what you would need to do is you would need to give it this full path right here, and then do the / and then cryptbot binary. So you would do the executable, and then you would give it the full path of where this binary actually sits. So in this instance, they just told us to go to the location of this binary, and then you just say / and then give it the name. And this dot represents the current directory that you're in, meaning it actually represents this location right here. And then you just do / cryptbot.binary, and that's it. So that's how you would run it, and then you get the report, and then it also generates the report output for you, which is what we see right here. We have the text, very verbose JSON, and very verbose text. So that is the intro to this thing. So now we're going to learn to dissect the results. The very first block of the output that we get has to do with the general information and the MITRE and MAEC data. So it gives us the algorithm hash values, which is, the MD5, SHA-1, 256, etc. It gives us the analysis field that shows us how Kappa performed its analysis on the file. The OS field reveals the operating system that we're on. The architecture field, or the arch, allows us to determine whether we're dealing with a binary related to the x86 architecture, and then the path itself is what we actually analyzed, right? So it says, I386, etc. So this is essentially what we just saw in the report in the last section that we were in. It gave us all the hash values. It gives us the type of analysis that it did, the operating system that it was running on, etc. The MITRE attack portion This gives us the adversarial tactics, techniques, and common knowledge. And this is a very comprehensive global repository, which we already looked at. And it functions as a strategic playbook that provides you details on what people have done. So you already saw that we had the initial access techniques, and then we had maintaining a presence, which is also known as persistence, escalating privileges, evading defenses, all of these things. And there's dozens. At the very least, I think there's like 13 or 14 different columns. And then within each one of those columns, there's like hundreds of strategies. So it's a very, very robust website, obviously. So the MITRE ATT&CK website, as you saw, has a lot of intelligence inside of it that you can use. So the format is what Kappa uses for its output, so that and just some of these results may or may not contain the technique and sub-technique identifier. So that's one thing to just keep in mind, I guess. So this is the format is like this. So you have the attack tactic, then you have the attack technique, and then you have the technique identifier. So defense evasion would be the tactic, the technique would be obfuscated files or information, and the identifier would be T1027. So this is defense evasion would be the tactic, obfuscated files would be the technique, and then T127 would be the identifier. Same thing over here. For the format that we have over here, let's see. So attack tactic, attack technique, attack sub technique, and then technique identifier, and then the sub technique identifier. So it's more detailed information. So defense evasion, obfuscated files or information, indicator removal from tools, and then you have the technique ID, and then we have the technique ID or the sub technique identifier, right? So tactic, technique, sub technique, and then the ID, and then the sub ID. So this is, again, the breakdown for it. So this is what we would see over here. So we have defense evasion would be the tactic, the technique would be this, and then the identifier is this. And then we have this again as the technique, and then we have the sub technique from the tools, and then we have the identifier, and then the sub identifier. Same thing for this virtualization, sandbox evasion, system check would be the technique, and then identifier, sub identifier. So this is the way that we can analyze this, right? So under defense evasion, there are, 3 overall techniques, and their relative sub techniques. And then we have under discovery 1 is there, execution has 2, 2, and then impact has 1, and persistence has 2. And all of this had to do with that same CryptBot binary. So in the Kappa's final output, they reference the MITRE framework. This helps analysts or defenders map the file's behavior to the adversary playbook, which can help narrow down the scope of the investigation during an incident. To dig deeper, you can go and look at the full videos that we have for MITRE ATT&CK. So essentially, when you see what attack tactics and techniques are associated with any given binary or any given attack, you can kind of guesstimate what their objective was, what they were trying to do, right? So they want to hijack your resources, they want to run some scheduled tasks at a specific thing. They're looking at scripting interpreters for PowerShell, so they're going to be using that. They want to go look at file and directory discovery, so it sounds like they're trying to do reconnaissance. They want to avoid evasion, or they want to avoid sandbox detection or virtualization, and they're looking at obfuscated files or information. This is some of their tactics to actually avoid your defenses. So once they've avoided your defenses, or evaded, once they've evaded your defenses and actually gotten into your network, what they want to do is they want to start looking around and do some reconnaissance. They're probably going to execute some command inside of PowerShell and try to access shared files and try to hope maybe hijack your resources or exfiltrate some data. And then what they're going to do is, in order to persist, meaning in order to actually stay in your systems, they're going to create some kind of a scheduled task that will run regularly, which will most likely execute some kind of a reverse shell that was generated for PowerShell. So I'm guessing, I have no idea if this is what they were trying to do, but this would be kind of the way the thought process would be. Okay, they want to evade the defense, obviously, because they want to get in. They're doing some reconnaissance. They want to execute some commands, and they want to hijack our resources or steal resources, steal data from us, and then they want to stay in our system. So they're going to use a variety of scheduled tasks to do it. So then there's the make or MAEC, whatever, the malware attribute enumeration and characterization, which is the language that's designed to encode and communicate complex details concerning malware. So it's an extensive range of attributes, including behaviors, artifacts, and interconnections among various instances of malware. And this language functions as a standardized system for tracking and analyzing the complicated complexities of malware. That's just a very fancy sentence. So the MAC category would be malware. MAC value would be launcher. So if we looked at the table to see the most commonly used values by Kappa, you would have downloader and launcher. Launcher exhibits behavior that triggers specific actions similar to malware behavior. Downloader exhibits behavior where it downloads and executes other files, usually seen on more complex malware. So once it's been launched, it'll download and execute other things. If it's just a launcher, then it'll trigger specific actions similar to basically whatever the malware behavior was. So these are two commonly used values by Kappa, which is either the downloader or the launcher. Now, obviously, if it's once you launch the executable, so let's say we launch that binary file. Once we launch that, if it starts downloading other things and executing those other files that it downloads, obviously it's much more complex than something that will just, once you launch it, it'll just do whatever it's trying to do on your computer. So if it's downloading a bunch of other things, that means it needs a bunch of other things, which means it probably is trying to do a bunch of other things. So Kappa tags a file with a launcher. It indicates that the file demonstrates behavior similar but not limited to dropping additional payloads, activating persistence mechanisms, connecting to C2 servers, and executing specific functions. C2 servers are command and control, which is basically somebody remotely connecting to your machine and then being able to take control of your machine from a remote location. And the C2 server would be the server that's existing somewhere different from your building, and it's connecting to your location, and then the attacker is connecting to the C2 server to use it as kind of a proxy between themselves and you, so that if you reverse engineer the connection and try to find where the C2 server is, you won't be able to find the attacker. You basically only find the server that they were connecting to take control of you. So some of these behaviors are also present in malware behavior catalog, which is MBC, and capability block, which we will discuss later. So when Kappa tags a file with a downloader, it means that it's going to fetch additional payloads or resources from the internet. It's going to pull in updates, execute secondary stages, and retrieve configuration files, which just by itself, just by that list of stuff, you can see that it's much more complex than the previous one. So what is the SHA-256 of cryptbot.binary? So if we go up here and just look at this, this is the SHA-256. Let me make sure I have the full thing highlighted. So we're going to copy that. We're going to go to the bottom and we're going to paste it over here. And that should be the answer. What is the technique identifier of obfuscated files or information? So we want the technique ID of obfuscated files or information, which is T1027. And that is that answer. Let me make sure I get that. Very good. What is the sub-technique identifier of the obfuscated files or information? So with the second item that we have over here. And the sub-technique is 005. So that one I can just type in. I don't need to do the whole. Oh, I need the full thing. So it's T1027005. Okay, whatever. Man, I could have just done that without scrolling up and down. Gosh. Okay, great. And then when Kappa tags a file with this MAC value, it indicates that it demonstrates behavior similar to, but not limited to, activating persistence mechanisms. So if it's activating persistence mechanisms, it means it is a launcher. So that's what we have over here. And when Kappa tags a file with the MAC value, it indicates the file demonstrates behavior similar to, but not limited to, fetching additional payloads or resources. So this is obviously a downloader. And voila. Okay, cool. So we got the general information and MITRE and MAC categories and all that stuff done. So now we need to look at the malware behavior catalog. Under the malware behavior catalog, we have the malware behavior catalog itself, so which is the catalog of malware objectives and behaviors. And then we have the objective, the micro objective, the MBC behaviors, micro behaviors, and then the methods. So let's look at the terminal output here. The terminal can also be in from task 2. So this is basically the same thing that we saw from task 2 when we looked at the full report. So the objective would be on here. So these are all of the objectives. So anti-behavioral analysis, anti-statistic, communication, data, etc. So the behavior would be virtual machine detection, executable code, HTTP communication. This was a long list. So if you remember, there was a lot of stuff that was available under this specific section. So we're going to look at the catalog to better understand the block that we just saw. So this is the catalog. It's designed to support various aspects of malware analysis like labeling, similarity analysis, and of course standardized reporting. So essentially it serves as a catalog of malware objectives and behaviors, and it can also link to attack methods from the MITRE framework to log all the behaviors and code features discovered during the analysis. It's important to note that the name of these behaviors may or may not match the corresponding attack techniques, and the information on behavior pages complements the content on attack pages. In other words, when recording malware behaviors, MBC uses references from attack, or MBC users will reference the attack, but MBC does not duplicate the attack information. So this is the content, as we can see in two formats, right? So the format is the objective behavior and then the method as well as the identifier. So objective would be anti-static analysis. The behavior would be executable code obfuscation. The method is the argument obfuscation. And then this is the identifier. Then we have the objective behavior and identifier. So communication, HTTP communication, and then that's the identifier. The difference is that the first format contains additional details called the method, which can also be coined as the sub-technique. So this is what we see right here. The method, which is in this case the argument obfuscation, that is the method or the sub-technique in this case. So objective. These are based on the attack tactics in the context of malware behavior, though they're not all included, and it has anti-behavioral and anti-static analysis. These objectives are tailored for malware analysis with the use case of characterizing malware. So this is the table that we have over here. So anti-behavioral analysis, anti-static analysis. I mean, I really don't want to read this whole thing, so I'll do this for you, okay? I'm just going to leave this here for a couple of seconds. Feel free to pause it, and then you can read through it, and then we will reference, I'm sure we're going to reference these to answer the questions that come up later. But this is just a bunch of data that's available for you, and you can get the full list of all of the stuff that's on the MBC, on the MBC by going through their documentation. So this is what is available for the, for the characterizing malware portion, I believe. And then so we have the view more objectives. So these are the rest of the objectives that are available. So if you wanted to, again, pause through this and read that. So there you go, 1, 2, 3. And then there we go, 1, 2, 3. And then we have the micro objectives, which are associated with micro behaviors, often referred to an action or actions exhibited by potentially malicious software that isn't necessarily malicious and may serve various objectives. These could be the stuff that's inside of messaging apps as an example. So it's important to note that these behaviors are typically abused. That's why Kappa might have flagged this behavior. So exhibiting behaviors related to processes that are not limited to creating processes, setting thread context, terminating processes, checking mutex, memory, meaning allocating memory or changing memory protection, freeing memory, exhibiting behaviors such as, but not limited to, DNS, the domain name system, file transfer protocol, hypertext transfer protocol, internet control message protocol, simple mail transfer protocol, all of these things, right? And of course, behaviors that check strings, compress data, decode and encode data, all of that stuff. Then we have the MBC behaviors. They contain behaviors and micro behaviors with their identifiers, and then we have the MBC summary for a listing of all of its contents, which is available on their GitHub repository page. And then you can see that there is a long list of stuff that belongs inside of this tool simply under the malware objectives for MBC. So let's just be let's be honest, let's be clear here. There's a lot of data, and to save time and to not bore you to death, I'm not going to sit here and read all of these things, but it's important to note that there's an objective, there's a behavior, there's an identifier, and then in this case, we also have explanations. So again, 3, 2, 1, and then we'll go here, 3, 2, 1. Feel free to read through that as you will. Micro behavior, also known as low-level behavior, refers to the actions that are exhibited by malware that aren't necessarily malicious and may serve various objectives. They're documented as micro behaviors in the MBC, and examples of such things could be the creation of TCP sockets and evaluating specific conditions with strings. It's important to note that just because a behavior is characterized as low-level does not mean it's harmless. So it doesn't mean that it's harmful, but it also doesn't mean that it's harmless, because this could still be a part of a larger scheme. So if it frequently utilizes memory allocation as a part of its strategy to unpack itself and execute malicious activities, malware creates a process via WMI or shellcode, is capable of initiating HTTP communication. It can inspect a string to identify specific characteristics, all of that, right? So, and then these are all the stuff that falls under the file system category: creating directory, deleting files, reading files, writing files, all of this information. And then we have the methods. These are included in the results from the previous example. They are tied to behaviors. Therefore, to fully see all of the methods, you got to refer to the actual behavior or the micro behavior that would be relevant. So the behavior, executable code obfuscation, and the method or sub-technique is the argument obfuscation. An explanation would be a simple number of strings and arguments. 2 API calls are calculated at runtime. And then for this behavior, again, we have stack strings. And then for HTTP behavior, we have reading the header, encoding data to base 64, encoding data to SOR, XOR. Obfuscated files or information again, and then we have encoding standard algorithms. So there's a lot of encoding that seems to be taking place. So maybe they're trying to format it for transfer, maybe they're trying to format it for further manipulation. So now that we understand this, we understand the overview of the MBC contents, we should be able to explain the result of the previous example. So we're going to do a quick recap of the results. So this is the objective, which is data, and then the behavior is to encode data base 64. So this is what we see. The MBC objective is data, which exhibits behaviors like checking strings, compressing, decoding, and encoding. The MBC behavior of encoding data has the ability to encode data using base 64 and SOR. Then the base 64 method is malware that's encoded using base 64, which we talked about in the CyberChef video, which was the last video. And then this is its identifier. So this is all of the data that we were able to pull from this portion right here, okay? So knowing this, you may simply say that this file can use base 64 encoding scheme. That's it, right? Nothing. Just that by itself does not seem malicious, because base 64 encoding happens a lot. It happens for a lot of different types of formatting. It makes easier to transfer data without using a lot of bandwidth. So it's not necessarily a bad thing, but it could be a part of a larger scheme of activities that could be intended to be a bad thing. Okay, so just keep that in mind, right? So we did, again, as they said, like, this may not necessarily by itself just be bad, because base 64 encoding is used so frequently across so many different tactics that are legitimate, but it could also be used to transfer data quickly and decode it later on when it receives to its when it gets sent to its destination. And then from there, now they've quickly transferred a bunch of data out of our stuff and they're exfiltrating data, which is it kind of ties back to the overall, when we looked at this step by step of the tactics and techniques. It's like, oh, okay, they're trying to evade defenses, they're trying to get in, they're doing some research, they're going to look at our files, they're trying to run some processes so that they can transfer data out, maybe they can steal some data, maybe. That's kind of what it feels like. So what serves as a catalog of malware objectives and behaviors, and this is the MBC. So let me see what it, malware behavior catalog, that's what it is. Malware behavior catalog, that's what it stands for. Cool. And which field is based on the attack tactics in the context of malware behavior? So in the attack tactics, so let's talk about that. It's fun to say that. So which is, I think it's behavior, right? So behavior is the attack tactics. let me find it for sure. It is actually the objective that's based on attack tactics. I love saying that. It's so fun to say. Gosh, I feel like I have like a very weird obsessive part of me that, like, when I find something that I like, I'm like, I'm just gonna say this until it loses its meaning. What is the identifier of create process micro behavior? The identifier of the create process micro behavior. So let's go find that. Okay, cool. Boom. There we go. C0017. What is the behavior with the identifier of B0009? So this is what I'm gonna do. I'm gonna copy that. I'm gonna do a Control F on my screen and then do Control V. And there are 5 locations that it's attached to. There's the question, of course. There is the identifier right here. So what is the virtual machine detection, right? Is that what the question said? What does it want? What is the behavior with an identifier? So the behavior with that identifier is the virtual machine detection. So there it is. Copy that, and then we're going to click down to go to the question. Come on, go to the question. There we go. Boom, just like that. Little cheats here and there. Malware can be used to obfuscate data using base64 and XOR. What is the related micro behavior for this? So obfuscating for base64 and XOR, which are right here. So the micro behavior is the MBC behavior encode data. Is that information? And which micro behavior refers to malware is capable of initiating HTTP communications? So it's capable of initiating HTTP communications. Let's go find that. It is right here. It's under communication, HTTP communication. I think that's it, right? So that's the micro behavior that they're looking for. Yes, excellent. Boom. And just like that, we were able to finish those questions. So now we can talk about namespaces. There are 2 main topics to keep in mind here. We have the capability and namespace, and we're going to be focusing on namespace right now. So this is the Kappa executable output, and it can be viewed in task 2 again because we have the full thing. And this was the long list of stuff that was available over there. So there's the capability and then the namespace that's associated with it. And the namespace seems to just be the path of wherever this thing has been associated with the actual capability itself. So whether or not the path is inside of the Kappa or inside of the computer is a different thing. So the content of the block is represented in this format. You have the capability or the rule name, we have the top level namespace, and then you have the namespace. So reference anti-VM strings is the capability, anti-analysis, anti-VM, and VM detection. That would be the top level namespace, and then you have the namespace, right? So namespaces group items within the same purpose. So anti-analysis, collection, communication, compiler, data manipulation. These are the categories. So these would be the top level namespace. Think of a top level domain, right? So top level namespace would be this, and then this contains a set of rules specifically designed to detect behaviors exhibited by malware, to evade analysis, so anti-analysis, collection, because it enumerates and collects data for exfiltration, communication, meaning that it will do different communication behaviors demonstrated, compiler, sets of rules to recognize specific build environments or compilers employed in generating executables, and of course manipulating data, which means altering data within the executable, or really string encryption or data encoding, anything else that has to do with the manipulation of data, which is it's a pretty big list. And then we have the other executables that are the other top level categories, right? The top level namespaces. So it's an executable. It could be a host interaction. It could be impact, meaning that it affects the computer's behavior or the program's behavior. And internal, meaning it's not intended by an analyst for reporting. Instead, they're meant for internal purposes with the Kappa tool. The library, so building blocks to create other ones. Linking, involved in linking or dynamically loading external code or libraries. Load code, malware family, nursery, persistence, runtime, targeting, a bunch of stuff, right? So again, just in case you wanted to read it. But again, you can also find this just looking at the Kappa documentation. So 3, 2, 1, if you want to read that stuff. We have 3, 2, 1, and then we're going to go here, 3, 2, 1, and then we're going to go down here, 3, 2, 1, and then so let's look at how this works by checking the table. So we have anti-analysis, and then the namespace is anti-VM VM detection, and then rule YAML file. So if you want to actually create or if you wanted to find a YAML file that actually has a YAML rule in it, which is used for detection, which is very useful. These are the YAML files that are associated with it, and then we have the explanation. And the same thing for obfuscation. We have the YAML files for creating YAML rules. Again, very useful, especially if you want to do detection engineering. YAML files are amazing. They're very, very useful, and they can be used in a lot of different contexts. So this is beyond the scope of this. There's a couple of videos on the channel about YAML, and Yara. So Yara rules and YAML files, all of these things are very useful for detection engineering, but that is beyond the scope of cybersecurity 101. So we only use anti-analysis as the top level namespace. Under this, we have grouped namespaces like anti-VM VM detection, obfuscation. Each has a collection of rules inside them that are also grouped together. For anti-VM detection, we have the rules of reference anti-VM strings targeting VirtualBox, right? Reference anti-VM strings targeting virtual PC, etc. Same thing for obfuscation. It has its own YAML. So do note that this is still under the anti-analysis top level namespace. So this is what it would look like visually. Let's see if we can open this up a little bit. That's not bad. That's kind of cool. Let me see if I zoom out of that. There we go. So there we go. Top level namespace, namespace 1, namespace 2, and then the rules that are associated with the namespaces. That's kind of the best way that we can look at it. There are still a few more namespaces under anti-analysis. If you want to look deeper, we can obviously go into the link that includes the Kappa rules for the MBC project. The MBC project is available at the MBC project GitHub, and then there's a bunch of different subcategories of, or I guess we can call it directories, subdirectories under it that you would be able to look for example, Kappa rules, or Cuckoo, or the MBC Markdown, MBC Sticks, MBC Sticks 2.1, etc. There's a bunch of stuff, and this is all under the malware behavior catalog. So just keep that in mind. So now let's answer these questions using the information that we just gathered. So which top-level namespace contains a set of rules specifically designed to detect behaviors, including obfuscation, packing, anti-debugging, exhibited by malware to evade analysis? So that would be the anti-malware, I want to say, or anti-analysis, I want to say. I think that's what it was. Anti-analysis. Which namespace contains rules to detect virtual machines environments? Note that this is not the top-level name or the top-level namespace. So it contains rules to detect virtual machine environments. So I wonder if I just copy this and search for it into the screen, if we can actually find it. And yeah, so there's this, and then we can go to the next one right here. So this is so it says not this one, right? So I want to say it is this. So anti-VM detection or anti-analysis, is that what it would be? So it says which namespace contains rules. So note this is not the top level name. So I see. So this is this piece right here. This is the actual namespace. That's what they're talking about. So boom, we got that. And then we're going to go over here and paste it. Boom. Which top-level namespace contains rules related to behaviors associated with maintaining access or persistence within a compromised system? So we'll do the same thing. And in this case, there is no block of text that's associated with that. So what we can do is search for maintaining access. I feel like that might be available. There we go. So maintaining access obviously has to do with persistence. That's kind of a gimme. I should have already known that off the top of my head, because persistence has to do with maintaining access. Which namespace addresses techniques such as string encryption, code obfuscation, packing, and anti-debugging tricks? So let's do code obfuscation. Could be the technique. So if we go look for this, there's 11 references to this. So let's see what we can find. Code obfuscation would be obfuscation, which is also under anti-analysis. So I wonder what it's obfuscation, right? That's the answer. So obfuscation. Which top level namespace is a staging ground for rules that are not quite polished? So let's go look for that. And there we go. We have it. It's like it's a little bit cheating, right? So the nursery is a staging ground that contains rules for those who are not polished yet. So let's go to nursery. Awesome. So proceed to the next task for the second part of the discussion, which has to do with capability. So we're talking about namespaces, and now we're going to talk about the capabilities. So now we have another table that has to do with the capability and the related top level namespace, the actual namespace, and the rules that are associated with the YAML file. So this is it. So let's look at this one. So capability, which is here, top level namespace, namespaces, YAML file, and notes. So check all rules under this namespace, clear. Click here. You may check the top level namespace for this, which is under anti-analysis, communication, so on and so forth. So feel free to read through that. We're going to have to do the command find portion of this to actually be able to find these things. And now we have reference base 64 strings, encode data containing a thread local storage, get a common file path, create directory, delete file, read file on Windows, write file on Windows, get thread local storage value, allocate or change RWX memory, create process on Windows, reference cryptocurrency strings, link function. This is insane. This is a very long list, okay? So to further explain this, we're going to check the first capability, which is the reference anti-VM strings. So we noted that the related rules in YAML format are referencing the anti-VM strings.yaml, and this is under the namespace anti-VM VM detection, which is also under the top level namespace anti-analysis. So this tells us that Kappa was able to identify that the potentially malicious software searches for VMware specific registry keys and the presence of VMware tools or other VM related elements by using the reference anti-VM strings YAML. So malware typically does this behavior to avoid being detected. That's why Kappa flagged it. So we can have another example, the scheduled task via scheduled task, basically, which is a part of the Windows operating system. So we note that the related rule in the YAML format, scheduled task via scheduled task YAML, is under the namespace scheduled task and the top level namespace persistence. So it could identify behaviors related to scheduled task within the Windows operating system. It might have recognized patterns indicating that the executable registers itself as a scheduled task to maintain persistence using the rule defined in the YAML file. So have you noticed something? The item under capability has the same name as the YAML file under the rule, which with the addition of a dash between the spaces, so scheduled task via scheduled tasks, and then scheduled task via scheduled task, which is this thing, right? So you have that with just a dash in the middle of it. Simply because the capability is the name of the rule. So we want to take note of some exceptions where the capability or rules are not located under the namespace. Let's take the capability reference cryptocurrency from the table above. This should be under the impact, which is what we saw. If you go through the folders, you won't be able to find the corresponding rules. It will be located under the nursery and is a placeholder that are not quite polished yet. So now that we have an understanding of capability namespace, we should be able to explain what we got from the actual scan that was ran against our binary file at the very beginning. So we have the capability, which is referencing base 64 string, and this falls under the data manipulation encoding base 64 namespace. So the explanation is here. The capability is referencing that. So it has the ability to encode data to a base 64 scheme. Top level domain name is top level namespace, is data manipulation. So it governs the behavior involved in altering data within the executable, and it can be considered data transformation of malware behavior encompassing actions like string encryption and data encoding. And then we have namespaces, which is the encoding and base 64, and rules for encoding and decoding data using base 64 and XOR. And the YAML file was reference base 64 string, and the capabilities is also the rule name with an additional dash. So reference base 64 string, which is what we see here, and this is the YAML rule for it, reference base 64 string YAML. So you may say this file can use the base 64 encoding scheme, which we established earlier. So it kind of feels like we just repeated the same thing, but we just got some more detailed information on how we got to that conclusion. So what rule YAML file was matched if the capability rule name is check HTTP status code? So it would be check HTTP status code.yaml. That would be it. What is the name of the capability if the rule YAML file is reference anti-VM string? So reference anti-VM strings. And which top-level namespace includes the capability or rule name to run PowerShell expression? So let's do that and then go and search for that. So run PowerShell expression is load code is the top level, right? Is that what it is? Let's see what this is. Yeah, top level is load code. So let's do that here. We're going to do load code. Check the conditions inside. Check for Windows Sandbox registry from this link. What is the value of the API that ends in EX? What is the value of the API that ends in EX is it looking for? That's kind of weird. Okay, so we're going to check the conditions. And then what is the value of the API? So YAML files are very, very useful. So the rule itself is this, and you can see it's kind of hierarchical. So this is the rule, and then there's some meta information about it, and then we have the features, etc. The meta information, in my opinion, really is kind of irrelevant. It's just basically the information about the rule. It's not that big of a deal. The features would be, okay, this is the API that we need under a condition. This is another API. This is the substring for it, and this is the string. And it says the API ending in EX, which is the reg open key EX. That's basically what we're looking for here. And so we're going to go over there, enter, and we are good. YAML files are very, very useful. And as you can see, they're not complicated to write, right? So again, with the exception, so you could technically avoid all of that. Like you could delete that whole thing as long as you have this section right here. This YAML file will be functional. I would not recommend that you would delete all of this. This is usually especially if you're planning on distributing it to other users so that they know what attack framework it was used, etc., etc. But if you're just trying to write it for your own environment to detect certain things, then you don't really need all of this, as long as you know how to actually write the rule, which again doesn't seem complicated, right? So it's like it needs to include this AND operator, which means that in addition to everything else, it needs to have this API, substring, and string. All of these things have to match because they are all under the AND operator, which means that essentially as long as all of these things are present, this rule is going to be triggered. So there is that. All right, so let's move on to more information and more fun. So what's nice about the Kappa tool is that when you actually use verbose or very verbose, it'll actually tell you things like, what rule was matched that actually triggered all of the data that we got. Excuse me, I keep hiccuping. So if you do it with Kappa and then you do very verbose and then you still do the analysis on that binary, it'll give you the results that we saw in our, we see that we have the very verbose output over here. So they generated a very verbose report for us that we can kind of see in our document here in our lecture notes. So we'll get more detailed results, and if we look at the get content, we'll be able to see all of the information that is available. So this is the web explorer that allows us to look at it if we wanted to look at it in the HTML format or in the JSON format that's available over here. So this is what it looks like. This is the web page for Kappa, and it gives you the information to actually install Kappa, the instructions to be able to install it, excuse me. And then this is a screenshot of when it analyzes it and you're using it inside of the GUI of the website instead of looking at it inside of your terminal. So the terminal sometimes isn't as user-friendly, and it's also not as organized as what you would see here, because technically it still has it, right? So it still has the data, the rules that were triggered, and then it shows you that 31 rules were triggered, 22 namespaces were generated, 9,522 functions, etc. All of this is for this binary. You have the SHA-256 hash value, so it's much more organized. It's a lot more user friendly to be able to look at it inside of an environment like this instead of having to look at it in a long text file or on your terminal. So what we're going to do is we're going to be able to explore this information. So we'll review some of the capabilities, and then this will give us a better idea. So we're going to go through the first example. We know the capability was to reference anti-VM strings targeting VMware, and the corresponding rule was anti-VM strings targeting VMware YAML. So this is the image. So we have this, and so we have the or regex VMware iVMware. So now we can see right here. So this is the or operator, meaning so if this shows up, right? If this regex pattern actually shows up and it's looking for VMware /VMware /I, and then inside of this, there is this specific string that is being searched for that shows up under the regex pattern. This is actually going to be triggered. So we're going to look at the rule's contents. Now we have the rule, and then we have all the metadata, as we already talked about, and then these are the actual key features of it. So it says or string. So let me zoom in on this a little bit better. So it says, features, and under the or operator, meaning any of these things. If any of these things are present, this is going to be triggered. So we see VMware I, VMware tool, a bunch of stuff. And then inside of the description, there's this string description, this string description, this. And these are all of the various options that if essentially any of these things are present, this YAML rule is going to be triggered. So under the features, string VMware I is being referenced by Kappa Web Explorer, and it's saying that under this namespace, we could identify strings with a value of VMware by using the conditions within the rule. And then this is what it will look like again. So up close function, and it matches host interaction process create. So this has to be present in it. So if it's going to create a process, or any of these things would be present. So schedule task exe, create, this would be a command potentially that would be run. Both of these are regular expression patterns, the regex patterns. So as long as these things are present in any of these elements, and it also matches a process creation, then most likely it's going to be triggered. So this also applies to this rule that we see right here, so which is the very first rule that we looked at. So features, again, this is the meat of the rule. So we can see that, yes, it has to match this, or this is available, or this is available, either of these two. So if it matches this and, right, or excuse me, if it matches, when it says and, means this has to be there, and then either of these have to be there. So when it says and this, and then or, meaning either of these two. So either this one or this one combined with this one. As long as those things are present, this rule is going to be triggered. This is beyond the scope of this video. I'm not trying to teach you how to write YAML rules, but I want you to kind of understand what this is like, right? So under the feature string schedule task create is referenced by Kappa. Kappa is saying that under this namespace and by using these conditions within the rule with regular expression patterns, we could identify strings with a value of schedule tasks and create. So this is our final piece right here. Another cool feature of this is the filter option and the global search box, which are helpful. So you could actually search inside of the information. So schedule tasks via AT, and it'll actually show you the rule that would be associated with it, and the namespace that's associated with it, and the attack techniques that's associated with it. So I would say the graphical version of it that's on the website is much more user-friendly and probably a better way to look at all of the information that we were just generated inside of that report, because I mean, it just organizes everything so much better. I don't understand why anybody would not use the Web Explorer. So the Web Explorer is available through this link that they gave to us, the Kappa Explorer Web. So this is also on the github.io, except it's not the GitHub repositories. It's actually the applications that are generated using the GitHub. So you can take note of this domain, or you can just go to that room inside of TryHackMe and get this link. So it's mandiant, mandiant.github.io/kappa/explorer. And you would end up on this page where you can actually either upload from a local file, meaning upload the actual file of the binary, or load it from a URL, or preview static code, or preview dynamic. So very, very useful. I think this is actually amazing. I'm going to save this into my my bookmarks because that is very handy. So let's see, we got a couple of questions here. So which parameter allows you to output the results of Kappa, into a .json file? So output the results into a .json file. Okay, so this one I actually Googled, and there it is. Which tool allows you to interactively explore the Kappa results in your web browser? And that would be the Kappa Web Explorer. Which feature of this Kappa Web Explorer allows you to filter options or results? And that was the last thing, which is the global search box, right? There we go. So the global search box allows you to filter options or results. And that's it. We didn't even have to use the virtual machine. If I had known, I wouldn't have even wasted the bandwidth on it. That's kind of silly. All right, let's talk about the conclusion real quick. Okay, so I mean, the conclusion doesn't really even give us that many notes either. It just says that we used Kappa to try to do some static analysis. And just for your own information, static analysis is when you look at something without running it. When you run it, then it's dynamic. You're actually looking at what it does dynamically as it's running. When you do a static analysis, you don't run the executable, but you're looking at all of its source code. And if you don't know how to analyze source code, this is where a tool like Kappa comes in, where it actually looks at all of the finer details for you and generates a very, very detailed output, a very detailed report, which is, I mean, very handy. I loved this. For me, this was the first time that I saw Kappa, so I'm actually very excited that it even exists. And now that I know that it exists, as you saw, I already bookmarked it because it's something that I know is going to be useful in the future. So I hope you, at the very least, you go to that domain name and you bookmark it, because you don't even need to have it installed on your computer. That's basically the final note that we got, is that as long as you have that web explorer, you don't even need to have Kappa installed. You can literally just go to that web explorer and attach the file or drop the code or whatever, and you can analyze whatever you need to analyze. If you found this video useful and you would like to get the rest of the videos in the CySec 101 training series, as well as all the other videos that are going to come out on this channel, I encourage you to like, subscribe, and turn on notification bell so that you get notified the next time that a video comes out. And of course, drop a comment if you have any questions, or if you want to say hi, or if you have any comments that you want to drop. But definitely make sure that you like, subscribe, and turn on the notification bell, because there's a lot of content that's coming out in the CySec 101 training series, as well as the AI for cybersecurity, and then ultimately pen tester and certified ethical hacker, and all of those stuff that's going to be coming out. There's a lot of stuff that's going to come out on this channel, and I think you will be very pleased by being a part of this community. So again, like, subscribe, turn on notification bell, drop a comment, say hi, ask a question, all that good stuff. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord servers. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video later. In episode 48 of the CySec 101 training series, we are going to go through the basics of Cyber Chef, which is a very powerful resource, and it is free and it's available online. And it's literally one of the most powerful resources that you'll be able to use when it comes down to encoding or decoding, or kind of decrypting in a sense, but not really. I think it has to do with more with encoding and decoding and formatting and things like that. And in a lot of cases, in a lot of environments, you're going to have to deal with either encoding or decoding, or formatting, reformatting, certain types of code or text and things like that. And you'll see what I mean as we go deeper into this. And this is part of the defensive security tooling module, which is inside of the cybersecurity 101 pathway of TryHackMe. And as a part of this video, we're going to go through the intro to CyberChef. Obviously, we're going to show you how to access the tool, which is very easy to do. We're going to navigate the interface of it and learn what the various locations or the different sections of the tool represent and what you can do with it. There's a segment called Before Anything Else. I don't really know what that means, but I'm guessing it's like some notices or disclosures that they have to give us. And then there's several practice exercises that we're going to run, and we are going to create our first recipe, or we're going to use our first series of recipes to create our first official cook, so to speak. So once we have that, we have the conclusion. I'm going to give you a couple of final thoughts and give you a couple of final resources and send you on your way, dismiss you from class for today. So that being said, let us jump into it. If you're serious about your CySec education and would like to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the CyberChef Basics room. So as an introduction, CyberChef is a web-based application. So it's a web application that you can access from your web browser, and it has a variety of cyber operation tasks that you can deploy, and they call it the Swiss Army knife for data. So essentially it has a variety, like a lot, honestly, probably a few dozen different tools that are designed to do any given specific tasks, and they just make your life easier. And it can be things like encodings like the XOR or base64 to complex operations like the AES encryption or RSA decryption. That's actually, I knew that there was some kind of encryption decryption mechanism that was available inside of it. So it operates on recipes, as the name implies. It's a chef, right? So CyberChef has a variety of different recipes, or also known as a series of operations that we can be executing in any given order. So you can essentially kind of combine the recipes together, and it will do a variety of different things in order based on the order that you've established those recipes. So in this particular case, for example, in this screenshot that you're seeing right here, the recipes that are coming into the conveyor belt, so to speak, is the XOR, and then there's base 64, and then base 85, and then we have extracting of an IP address, we have Morse code, and each one of these things, assuming that these were actually a part of the overall recipe that was used, or the overall cooking segment that was used, all of those things would be processed in that exact order. So the objectives of this video are to learn what CyberChef actually is, how to navigate the interface of it, understanding the common operations available inside of it, and of course how to create recipes and process the data that you generate with those recipes. You do need to have a basic understanding of hashing and cryptography, and both of these rooms have videos that are created for them inside of this training series that you're watching. So in the CySec 101 playlist, towards the very beginning, I would say it's probably like the first 10 videos maybe. Yeah, it's towards the beginning at least. It's definitely the first, like within the first 20 for sure, but I think it's also within the first 10. And then it's in the title where you see cryptography basics and hashing basics, and it's just good to understand what these things are. So if you don't know what hashing is, if you don't know what cryptography is, I would highly recommend you watch those first, because we are going to be talking about those things inside of this video, and we're going to be using a lot of those concepts with the tasks and the exercises that we're going to be running. And if you don't understand the basics of those, you're going to have a hard time with the rest of this stuff. So that being said, now we're actually going to access the tool. Every time that I've accessed the tool, it's been online and I just use it through my web browser. You can also use the offline or local copy where you can actually download the most recent release from their GitHub repository. So it's actually a GitHub available. It's a GitHub repo that's available on GitHub, and it was created by whoever this person is, GCHQ, the UK's Intelligence, Security and Cyber Agency. Okay, so this is actually an organization that created this, which is awesome. CyberChef is one of their repos, and it's a very powerful freaking repo. So you can download it locally on your computer. The most recent version, obviously. The reason why I use the web-based version is because it just gets updated, and anytime that I use the web-based version, I'm using the most recent version. And so this is the link that's available for it. And again, this is a GitHub repo link, but every time that I access it, if I don't have like a link like this that's available, I will literally just do CyberChef into my search browser, and it's the very first link that pops up. So CyberChef GitHub pages, and then you open it, and it brings you exactly into the CyberChef tool. And as you can see, we have a cool interface with a variety of different things. I don't want to jump ahead, but that's basically it. That's how you access it. You can either download it from their GitHub repository and store a local copy for yourself. You just need to make sure that you update it regularly, or at least check for updates regularly, so that you can have access to the most recent recipes and the most current recipes. Or you can just access it online through your web browser, and you are sure to get the most recent version of it. So that being said, now we're going to learn about the interface of CyberChef. Okay, first you need to see the actual interface. This is the interface that we have over here. So it has 4 sections: the operations, recipe, input, and output. And as you can see right here on the left-hand side, we have the operations. Right in the middle, we have the recipe, which is pretty much kind of like the central portion of this. And then there's the input, meaning you can either paste data into here as your input, or you can actually even attach files, right? So you can add a new input tab, open file as an input, clear the input and the output, etc. And then whatever you input into here, it will automatically get processed according to the recipes that you have chosen, right? Or essentially the operations that you choose as a recipe. So for example, if I take something from base64, it will automatically, if I drag and drop it here, if I have any base64 encoded data, I can put it in here as my input, and it'll automatically decode it for me. And this is essentially it. You can click bake down here, which is the button that kind of does it for you. But every time that I've used this, it automatically just creates the output for me as I put in the input. So that part, I've never actually had to click the bake button. For me, every single time that I've ran it, it's done it automatically. But this is the general interface that you see right here. You can also save your output to a file. So save output to a file. You can replace the input with the output, meaning you can switch it back and forth, the data between these 2 boxes that you see over here. And you can even make this thing maximized to see what the output potentially might be if you really are getting like a robust output and you need to be able to decipher it a little bit easier in a larger window. So let's look at the details of these portions. So again, we see them over here: operations, recipe, input, and output. And the operations area is the comprehensive repo of all the operations that CyberChef can actually do for you. They are meticulously categorized, and they offer user convenient access to various capabilities, and users can utilize the search feature to locate specific operations quickly, enhancing their efficiency. One of the big things that I use all the time is when I need to defang something or I need to fang something. So you'll see that a lot, especially when you're creating reports to deliver to the C-suite people or to executives. You need to defang all of the IP addresses and all of the URLs. And to defang something means that you make it so that people can't accidentally click on it. So you make a URL not clickable, right? So we can do defang, and then you'll see defang URL or defang IP address. So I'll do defang URL, and I will go ahead and drag this over here. I'm just going to delete this, or I can just deactivate it, as you can see right there. So if you press that, it's like the stop button or the stop sign kind of, so it disables the operation for you. You can also just drag it off and drop it off, whatever. So we have the defang URL. So now I can go over here, right? And I can just give it a URL. So it'll be www.google.com. So this is the actual input, right? The output is automatically updated, and this is the defanged version of it. And really all it does is that it puts these square brackets around the major elements of the URL. So if I actually went over here and turned this into HTTPS and then did the forward slashes, then it will actually even put the square brackets around these major sections. And so what this does is that it makes it so that this, and oh, by the way, it turned HTTPS into HXXPS, right? So it has turned this full URL into a non-clickable version of itself, so that somebody who's going through the document that you've created, the report that you've created, they don't accidentally click on this. And you can do the same exact thing with an IP address. So if I actually went over here, I wonder if it'll work if I don't use the defang IP address. It doesn't work. So we actually have to use the defang IP address. So I can just drop that over here, and it automatically works with the defang IP address as well, and it just puts the square brackets around the dots. And so notice that we have both the defang URL and the IP address that is available over here. And then if you wanted to, you can choose the various things to escape. So you can, if you do escape dots, it'll put these square brackets around the dots. If you do escape HTTP, it'll actually put the square brackets, or it'll change HTTP into HXXP, as you just saw. And then escape these colon forward slashes, meaning it'll put these square brackets around them. If you turn this off, it won't put the square brackets, it won't change the HTTP, and it won't put square brackets around the dots. So this is a very, very basic example of what you can do with it. But again, this is just the list of operations that you can use, and you can search for them. That was like the whole point of that rant that I just gave you, was to show you that you can actually search for something, because a lot of times you don't know where it's going to be within all of these various categories that you have, right? So that's the operations list. And so these are some of the more I guess important ones, or some of the more operations that you would use out throughout the cybersecurity journey. So you want to turn something from Morse code, meaning translate Morse code into uppercase alphanumeric characters. So in this case, this Morse code turns into threats, which is very cool when you really think about it. This gets turned into the actual word for it, which is threats. URL encoding encodes the problematic characters into percent encoding, which is a format that's supported by URL. So for example, in this particular case, HTTPS will be turned into this version. So this is what URL encoding looks like. Let me see why this is actually not looking the way that I want it to. So let's zoom out. Maybe that's the reason why. Let's do that a little bit more. All right, so that's probably the best version of this. So I will zoom in manually. So this link will then become into this whole thing right here, where you can see that the colon forward slashes have been turned into these percentage encodings and these characters that are available. So the %2f represents this forward slash, right? %3a represents this colon that you see right here. So this is when the encoding all of these special characters portion of URL encoding comes in. You can turn something into base 64, so it encodes raw data into the ASCII base 64 string. So this is fun, becomes that right there. It 2 hexadecimal converts the input string into hexadecimal bytes. So this hex becomes this right here. So this sentence right here becomes this whole hexadecimal portion. Then we have 2 decimal, which turns this into decimal formatting, decimal encoding. And the technical term is it turns the input into an ordinal integer array, is when you do 2 decimal. And then we have ROT13, which is a Caesar substitution cipher, which rotates alphabet characters by the specified number. The default would be 13. So this is the actual cipher, and we talked about this in the cryptography video. So this is it actually encodes something into that. So it'll take digital forensics and incident response, and it'll turn it into this right here. This is technically an encrypted message. So as long as you know what the key for the cipher is, which means it basically moves everything by 13 characters. So D becomes Q, and then I becomes V, and then G becomes T, and then I becomes V again. So that's essentially it. So if you know that if you move 13 characters back, you can actually decode this, and the key in that regard, in that moment, would be that it's 13 characters, right? So the default is 13 characters. So as long as you know that you're using this Caesar cipher, and you know what the key is, meaning the number of spaces that it's actually moving, then you'll be able to decrypt any message that has been encrypted using the Caesar cipher. So you can directly check on how the operations work by actually hovering over them, and you'll get an explanation. And then we have the recipe area. So the recipe area was this central portion, this piece right here that you see. And the recipe area is considered to be the heart of the tool. In this area, you can seamlessly select, arrange, and fine-tune operations to suit your needs. This is where you take control, defining each operation's arguments and options precisely. And it's designed as a designated space to select and arrange specific operations, and then define their respective arguments and options to customize their behavior. So it could be something like save recipe, load recipe, clear recipe. These are the options that would be available for you. And you already saw that we were able to use several various recipes as we just did that defanging exercise. And the bottom part is where the bake button is. For me, auto bake was actually clicked. I think that's what it is. So that's the reason why we have this, all of these things are actually happening, is because I actually had auto bake clicked every single time. That's why it's doing it automatically. So I thought I was special, but in actuality, I actually had that auto bake button that was clicked. So that was it. Then there's the input area. So we can paste input, we can type input into it. We can obviously import files into it as our input. You can have a new input tab where an additional tab is created for you to use different values. And of course, you can have as many tabs as you can see right here. You can open an entire folder as an input. You can open a file as an input. You can clear the input and the output. And of course, you can reset the pane layout, which brings the tool's interface to its default window sizes after you've done modifications. Because you could technically actually just kind of switch these things back and forth, as you see right here, to be able to look at the various locations here. And so if I do something like this, and then I click this reset pane layout, it takes everything and sets it back to default. So then we have the output area, which is the space that showcases the data processing results, and it neatly presents the outcomes of any manipulations or transformations, assuming that you've chosen the right recipe. So that's the piece right there. So if you chose the wrong recipe, then you're just going to get jargon. And that's the thing that makes it a little bit tricky, because you really need to know what type of input data you're actually dealing with and what recipe to actually use to go ahead and decode it for yourself or decrypt that data. You can save the output to a file, copy the raw output to the clipboard, replace the input with the output, meaning just swap them. And then we have the maximizing of the output pane that breaks it into full screen mode so that you can go ahead and try to figure out what the hell is going on. So in which area can you find from base 64? So that is an operation. And then from which area is it considered the heart of the tool? And that would be the recipe portion. So before anything else, the overview of the thought process or the thought process when you use CyberChef is one of the big things that we need to cover, so that you just kind of understand it. It's not really that big of a deal. It's not complex or anything, but it is important to understand. So the very first step is to have a clear objective of what it is that you're trying to accomplish with CyberChef, and then put the data into the input area, select the operation that you want to use, and then check the output to see if the results that you wanted actually came out. If not, then you need to repeat this process multiple times to get the results that you wanted, which means that this clear objective portion is pretty much, I would say, the most important part of this, because if you know what type of data you're dealing with as an input, then it's only a matter of time until you figure out the appropriate recipe to decode or to, let's say, get a plain text version of the data, or whatever the type of output it is that you're actually looking for. If you don't know what type of input data you're dealing with, you're essentially going to go through the entire freaking list, which is not a bad idea. Like, if you don't know what it is, the last resort is, okay, just go through everything that's inside of the CyberChef operations, and at some point you'll find something. But that can take a very, very long time. So if you know what kind of data you're dealing with, you're pretty good to do. You're pretty good to go. So the clear objective is essential, right? This involves defining specific and achievable goals. It helps answer the question, what do I want to accomplish here? And objectives are vital in providing direction, purpose, and focus to your goals. One example would be, during a security investigation, I found a gibberish string. I want to know what hidden message it contains, even if it has one. Then you put the data into the input area. You use your data where you paste or upload the gibberish string that you found, and then you use the operations that you want to use. This can be tricky if you're not familiar yet with what you're dealing with, right? So following the example, we're still determining what to understand about the gibberish string. So during the research, we found relevant information that this gibberish string might be using anything related to encryption. Therefore, we decided to use anything or any of the operations under the encryption encoding category, which at least narrows it down from this entire list of stuff that you see over here. And you go to encryption encoding, and then you just have, you know, a few dozen options that are available. And then what do we have? Including but not limited to ROT 13, base 64, 65, ROT 47. So we can use a lot of operations under that category, as you just saw. And then you check the output to see if you got the actual result that you were looking for. So have we achieved our objective is the big question that you need to answer. So what are you trying to do? And then have you done what it is that you're actually trying to do? Those are the two big questions. So you need to be able to decode the gibberish string that you found, right? That's kind of the example that we're in right here. If yes, then great. If not, then you need to repeat that process until you have actually found what you're looking for. To provide visual clarity, this is another version. So we have, let me see if I can zoom in on this a little bit. So during a security investigation, I found a gibberish string. Oh, this is literally the same thing that they just covered right here, so I don't need to go through that. So at which step would you determine what do I want to accomplish? I don't know. That would be step one. So your objective. What is your objective? Do you have a clear objective? If you do, the rest of it should be relatively easy. And for me, the part of the objective is, do I even know what kind of gibberish string I'm dealing with? If I know what type of data that gibberish string is, it makes the rest of it a little bit easier. Now, we live in a world that we have access to Gemini AI, Meta AI, ChatGPT AI, or whatever your favorite language model is that you can work with. So one of the greatest tools that are available to your disposal is, hey, what is this gibberish string? What do you think this is? And then you paste it, and it says, oh, I think this is base 64 encoded data, whatever. And then you're like, oh, cool. Then you take that gibberish, because it's not going to decode it for you. In a lot of cases, there's been safeguards put in place to prevent these tools from doing cybersecurity activities for you, or pen testing exercises for you. And you really have to kind of like finesse the systems to try to get these tools to actually do things for you. So one of the greatest things that you can do is at least, can you help me identify what type of data that I'm looking at? And then you go use CyberChef to create a recipe to actually help you understand that data, get the plain text version of that data. So now we're going to actually do some practice. For this practice, they've given us some task files here, and they also are telling us which specific tools we're going to most likely be using. The first category is the extractors. So it'll extract IP addresses, extract URLs or email addresses for you. And basically any IPv4, IPv6 address, extract email addresses, so anything that looks like an email address, and of course anything that looks like a URL. So that is the various extractors that are available for you. Excuse me, I keep hiccuping. And I would not be surprised if the extractors recipes are working with regular expression patterns. So if you, for whatever reason, can't access CyberChef, if you know how to use regex patterns, you can extract domain names or email addresses, for lack of a better word. You can extract email addresses or IP addresses or URLs if you know how to write a regular expression pattern. Date and time fall under the date time category. So from Unix timestamp, it converts a Unix timestamp to a date time string, and then to Unix timestamp, which parses a date time string in UTC and returns the corresponding Unix timestamp. And so Unix is the original operating system kind of foundation that ended up being the fundamental foundation for Linux being developed, and Mac OS is actually also running on top of the Unix operating system. So Unix timestamp is a 32-bit value representing the number of seconds since January 1st, 1970. To convert this into a Unix timestamp, we use the toUnix timestamp, and then it would be this thing right here. So this is the number of seconds since January 1st, 1970 UTC. It's actually a very, very interesting concept when you think about it. But yeah, literally it looks at the current time that we're at, and then it looks at how many seconds from that time, from this time, how many seconds from January 1st, 1970 does it take to get to this date right here, September 6th of 2024, evidently. So then you have the data format section. So we have from base64, so it will take it from base64 and gives you plain text. URL decode will take the percent encoded characters from the URL and just give you the normal URL. And from base65, so it will take it from base65, give you plain text, and then from base58, from that gives you plain text, and to base62. So the same way that you can take something from the encoded version and give you plain text, you can also so you can decode something from the encoded version to plain text. You can encode plain text to whatever the encoding is. So you can go to base62 and to base64, to base58, etc. So you can go back and forth, right, between whatever it is that you are trying to encode or decode, whatever that formatting is. This takes binary data, strings of zeros and ones, and transforms it into text-based representation using a specific set of American Standard Code for Information Interchange, so ASCII. So these are the base 64, 85, 58, whatever encodings. We have a dedicated room for hashing. We can also look at the various commonly used operations, which is the base 64 encoding. So, I mean, I'm really not going to try to explain this because usually my own brain starts to crash when I try to explain these things, and do it at the very least in like the most clear way. So if you want to view the complete ASCII table, you can actually go to the ASCII table page that's available at this link, which is essentially their Wikipedia page. And so the decimal 65, the binary is 01000 da da da. The symbol would be A, and so the decimal 78, this is their binary. The symbol would be D of N, etc. So these are the decimal versions of the letters, right? And then these are the binary versions of the letters. And so this is what it actually looks like. If you wanted to go through A through Z, this is what their decimal values are, and this is what their binary values are. So if we want to convert to binary and merge manually based on the above table, T would be this binary, H would be that, M would be that. Next, you concatenate them together, and so this is what that full string would look like in binary. So this technically says THM, right? That's the binary for THM. If you want to divide and convert to decimal manually, you would separate this into 6 characters each. So you would have 010101, so that would be 1 character, and then 000100 would be another character right here. Then we have the 100001, that would be another character, etc. So these are 6 characters or 6-bit characters, and we should have 4 instances, meaning this should be technically 24 characters divided by 6. You would have 4 various letters or decimal versions. So 0100 would be 21, this would be 4, this would be 33, this would be 13, and then we would then convert this into their letter equivalent. So this would be the actual table for that. So 21, if we found it, would be right over here. It would be V. 4 would be E. 33 would be H. So VEH. And then 13 would be N. So VEHN would be our response. There we go. I should have just read through the answer. So VEHN technically, so that's not amazing. Really, I mean, it is what it is, really. I don't understand why. Maybe that's like the password or something. So you uncovered a set of characters into base64 manually, or we converted it manually. So the decode version, this works by converting the percent encoded characters back to their raw values. For reference, we can check this page right here, which is the percent encoding Wikipedia page, which also gives you the various tables and keys, I would say, for doing something like this, decoding something. So the default character is set in HTML5, which is UTF-8 formatting. So check the table for a quick overview. So this character would be turned into this, right? This character is this character is this, so on and so forth. So the practical exercise now that we have the practical exercise, I really hope I don't have to do this. I'm definitely not going to do it manually. I'm telling you right now, this is a video on CyberChef. You better believe I am not doing any of this stuff right here. I'm going to go find recipes, and that's how we're going to find the answers. So we're going to download the task file. And then once downloaded, you can open it and copy paste the content into the input field, or use open file as input to upload the file. And the specific operations under the extractors category for the first two questions, it's best to try to answer the questions first without using the hints. And that's exactly what we're going to do. So we're first going to download the task file, and then I'm just going to upload it as a file. I'm going to add the file as an input. So there's that. So let me go ahead and it's extractor. I wonder if I could just drop it in here. Boom, I dropped it in there. Cool. So that is this tab. So it actually created a new tab for me, which is really nice, instead of me having to get rid of this old tab, which I'm going to do anyways. So this is our new tab. This is the file that was added. So the importance of continuous, etc., etc. So the first thing that we want to do is we want to extract some things. So I'm going to go to the extractors portion. And so what's the first question? The first question here says, what is the hidden email address? What is the hidden IP address that ends in 232? And which domain address starts with the letter T? So let's do this. Let's first extract email addresses. And then there it is. So that's our email address. It's hidden at hotmail.com. So let me make sure that this is actually copying. There we go. So the email address is hidden at hotmail.com. What is the hidden IP address? So we're going to remove this guy, and we're going to do extract IP addresses. And there we go. So we have two IP addresses here, and they're looking for the one that ends in 232. So I will copy that and come over here and paste that over here. Which domain address starts with the letter T? So we want to extract a domain. So we have the domain recipe here as well. So let's extract domains. And it starts with the letter T, so that would be TryHackMe.com. So I'll just type that. What is the binary value of the decimal number 78? So the binary value of the decimal number 78. So the recipe that we're going to look for is 2 binary, I would say. So I'm just going to type in binary. And it says 2 binary as my first option right here. So that's going to be the one that I'm going to do. I'm going to go right here, just type that. I'm going to create a new tab just in case I need that. And they want the binary value of the number 78. So we're going to do that. And there we go. That's the binary value of the number 78. Going to copy that bad boy right there. Let me just make sure I'm copying it. Okay, cool. The binary value of the 2 binary, right? That's it. So why is it giving me 2 different values here? That can be it. The answer is incorrect. That's not right. So what does the hint say? It says combine the operations from decimal to binary. From decimal. Oh, I see. The decimal number 78. Got you. My bad. Okay, so the 2 binary part is okay. So I need to do from decimal. I didn't understand the question well enough. I think I should have paid attention to the question. So now when we take it from decimal to binary, and notice how this is the order, right? So first it's taking it from decimal, and then it's turning it to binary. And so it takes 78 and gives me this right here. So that would actually be the value, and I think that would be the answer. That would be correct. Very good. So what is the URL encoded value of this domain? So we're going to take this, copy it, we're going to go here, and we're going to paste that over here. And I'm going to take this and then take this, and we are going to URL encode. So we're going to drag that, and we should have, right? So URL encoded value. So encode all special characters. Let's do that. And then now we have this value down here, which is going to be our TryHackMe careers domain name, and kaboom and kaboom, kablow. We got it. Zoom out. What are you doing? Cool. You got it. Look at that. The answer was correct. We got it. Everything is all good. I'm super happy that we were able to do that. Hopefully you were able to follow along with me. If not, you can just rewind it and watch everything that I did. The hidden email address was used from the extractions. So you can extract email. This was extract IP. This was extract domain. The binary value of the decimal number was, first we did from decimal to binary. So there was two operations that we used to create that recipe. We went from decimal to binary, and we were able to get this. And then URL encoding was URL encode. That was literally the only thing that I used over here. And then I just made sure to check encode all these special characters, and I got the answer. So now we're going to move to our first official cook. So we're going to use everything that we've learned to cook something, I guess. So what is the idea here? Oh, they really don't give us anything. You just got to kind of go through the motions. So it's best to try to answer without hints. Got it. So using the file you downloaded in task 5, which IP starts and ends with 10? So let's go back to the file that we had, which is this piece right here. We're going to take off the URL encoding portion, and then we're going to do extract. Or actually, I won't even do that. I'm going to go to the extractors because that was easier. So we want to extract IP addresses. And so it starts and ends with 10. So 1010 to 10 is the IP address for this answer. What is the base 64 encoded value of the string nice room with the exclamation? And it's actually a capital N and a capital R. So all of those things are going to make a difference. So we want the nice room with a capital N, capital R with an exclamation at the end of it. So I'm just going to copy that, and I will go ahead and remove this, and we will go back to this portion. So we can just paste something in here. And what do we want? The base 64 encoding. So we will go here and we will do to base 64 and then drop that operation there. And there we go. So this is the base 64 encoded value. Take that and drop that right there. Cool. So far, so good. And so just so you can see, 2 base 64, and then in the, and then in the middle right here, we have 2 base 64 alphabet. There's multiple options that you can choose for this, but I chose the default that's available for it. So we don't need to change any of that stuff because we're essentially in the introduction to CyberChef. So you really don't need to worry about, unless they instruct us to do it, we don't need to worry about any of that stuff. What is the URL decoded value of this, right? So we could actually technically do this ourselves, because if you just know what a URL looks like, you can technically just do this. And it's https://tryhackme.com/room/cyberchef basics. That would be the answer for the most part. I'm just guessing, but I'm pretty sure that's what the answer is. So I'm just going to paste this right here. I will deactivate that recipe because I feel like we're probably going to end up using it again. So we are going to do URL decode. So I will just drag and drop that over here, and then we literally have it right here. Oh, so I actually missed this R room portion. So I was close though. So that was it. So there we go. Boom. And then what is the date time string for the Unix timestamp? Boom. That's amazing. So we're going to go, and I'll just deactivate that, and I will paste this. And then what do we want? We want the date time string. So let me see if I can get date time delta from Unix timestamp to Unix timestamp. So we're going to end up using from Unix timestamp, and it actually gives us the date time string right here, Sunday. So let me make sure I copy that. So Sunday, September 1st, 2024, and that should be it. Cool. And what is the base 85 decoded string of this specific value? So let's copy this bad boy, go over here and paste that into our input. And then we're going to turn that off. And I guess I don't need anything that I've used before, but we will do base 60, no, not 60, base 85. So not base 65, base 85. And we're going from base 85 to plain text. And this is fun, is what it says. And honestly, this is fun. This is like easy. This is so easy to be able to use a tool like this. If you had to freaking use that table with the decimals and the decoding and all of that, then this would not be fun. But when you have a tool like CyberChef, it's like it's nothing. You're just copy pasting, dragging, dropping. It's so freaking easy. And that was it. That's the whole room. We're officially done with the room. So that was it, my dear friends. This was a free room. I should have mentioned it at the very top of the video. Anyone can deploy the virtual machine. I mean, there was no virtual machine, and really all you had to do was just kind of follow along and mess around with CyberChef in your own environment on your own browser. So not hard to do, very, very easy to interact with it, as you just saw. So I hope you actually used CyberChef as we were going through this, and you kind of messed around with all of the various exercises that you possibly can. And I hope you had fun with it, because this actually was fun for me. So that's pretty much it for CyberChef. This is the very first one in the defensive security tooling. And then we're going to go and cover 3 other tools. And then from there, we're pretty much going to be done. So let me just kind of zoom out for you. We're pretty close. So we just did CyberChef Basics. We have Kappa, Remnux, and Flare VM. And then after that, it's just talking about the cybersecurity career pathway and the various different elements that would impact somebody's career in cybersecurity. So for the actual content portion of this, for like the technical stuff and the information stuff for skill sets, we have 3 more videos after the one that you're watching right now, and we'll be done. And we'll officially be done with the cybersecurity 101 pathway of TryHackMe. So if you've hung out with me the entire journey, and if you've watched all of the videos that I've posted on this pathway, I am extremely proud of you, and I hope you are getting a lot of value from it. I don't want to jump ahead because we still do have 3 more videos, so I will recognize you and give you my full recognition when we actually get to the very last video. But we are in the home stretch. We're near the end. So I hope you are having fun with it. I hope you've been learning throughout this whole time, and I hope you will finish the rest of the pathway with me. If you did find value in this video, and if you found value in this series and you want to get the rest of the videos from this series, I recommend you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And this includes obviously all of the future stuff as well, because CySec 101 is not the end of this whole thing. We have a lot of great stuff that we're going to be covering, including AI for cybersecurity. That's a really, really big one that's going to come out. Make sure that you drop your comments if you want to say hi, if you have any questions that you want to ask me. I am very responsive in the comments section, so I will definitely get to your question and or comments. And that's pretty much it. So again, like, subscribe, and turn on the notification bell to get notified the next time that a video comes out, and all of the future videos that come out on this channel. And make sure that you drop a comment. If you're serious about your CySec education and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content, and the agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the comment section. If not, I hope I see you in the Discord servers. And that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. In episode 50 of the CySec 101 training series, we're going to go through the Remnux room, and this is a specific distribution for Linux, which is focused more on the defensive security aspect of it, and it includes tools for incident response, as well as security analysis and investigations for digital forensics. So a very powerful distribution of Linux. And of course, this is a part of the defensive security tooling module, which is a part of the cybersecurity 101 pathway of TryHackMe. So I am very excited to actually go through this with you. It has the of course, we're going to use a virtual machine for this. We're going to go through file analysis, fake network to aid analysis, memory investigation, evidence processing, and the conclusion. This is a subscriber only room inside of TryHackMe. So if you want to get a membership to it, you can use the link in the description below and you'll get a discount on it. And specifically, it actually offers Remnux, is what I'm talking about. It offers kind of like a sandbox environment for you to do everything that you need to do for your investigations, as well as incident response, as well as security analysis. So it's a very powerful distribution. Very excited to share it with you today, and that's what we're gonna be talking about. If you're serious about your CySec training and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhacks/hackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Remnux room. So if you've done anything inside of cybersecurity before, you can understand that there's a lot of different tools that are available for a variety of different scenarios and use cases. And usually when you're going through some kind of an incident which is ongoing, meaning it's continuous, it hasn't been resolved yet, and you need to address it by using a large variety of different tools. The way that if you can consolidate all of your tools into one location, it ends up saving you a lot of time and energy and ultimately headaches and things like that. And so Remnux is meant to be one of these distributions of Linux that can actually do that for you. As you can see, it's kind of out of the box. There's a bunch of stuff that's coming out for security, for decryption, for searching, etc. So this is the specialized Linux distribution. It includes Volatility, Yara, Wireshark, OldDump, and iNetSim, and it has a sandbox environment for dissecting potentially malicious software without risking the primary system. And it's already set up in our lab, and that's what we're going to be using. And so we have, exploring the tools that are inside of it, learning how to use those tools to analyze potentially malicious documents, learning how to simulate a fake network to aid in the analysis, and the familiarity with the tools that are used to analyze memory images. So these are some of the objectives of this video today. The prerequisites for this are the CyberChef Basics video, which is the last video right before this one. So if you haven't seen that one, I do encourage you. Actually, it's not the one before this one. It's the one before that one. So we had Kappa right before this one, and then CyberChef is the one before that one. So 2 videos ago, essentially, is when we did CyberChef. So very, very useful tool as well. CyberChef is amazing, and as you go through it, you'll actually see how amazing it really is. And we use it a lot in a lot of the exercises that we've done on this channel. This is a resource. It's probably the one resource that we have visited the most across the entire channel, because there are so many different applications for it, and it makes life so very easy when you're dealing with formatting for encodings and decoding, and formatting for encryptions and decryption, and I mean, a lot of stuff. So extracting data from files, or extracting data from large blocks of text, and etc., etc. A lot of very, very useful stuff comes out of CyberChef, and we're going to be using it for this video as well. So these are the objectives. That's the prerequisite. Now let's jump into the actual machine setup. Actually, I think I've already done this as well, so I don't need to really do this here. But this is a virtual machine that's available to us that has the Remnux distribution already installed. So we're just going to be using that. You can get Remnux from the Linux website specifically, and I'll show you exactly where that is. The official website for downloading Remnux is indeed remnux.org. So just make sure that you download it directly from this website. Don't go crazy and download it from a pirate website or some third-party distribution. Anything like that. Make sure you direct all of these types of installations and operating systems from the direct website itself, mainly because you'd never know what people may have injected into these download files, and You don't want to mess with that. So this is the actual website to download Remnux. You can install it on a USB drive and boot it directly from a USB, or you can download it as one of your virtual machines using a tool like VirtualBox or something like that. So this is how you would get Remnux to install on your computer. And then once you have this, you can go ahead and run the rest of the exercises with me, or if you have TryHackMe, then you just log into the room with TryHackMe and then we can run the exercises together. All right, so for file analysis, there is a tool available on Remnux called the oldump, which is actually a Python file. So you can use that to do static analysis on a potentially malicious Excel document, and it analyzes OLE2 files, commonly structured storage or compound file binary format. It stands for Object Linking and Embedding, and it's a technology developed by Microsoft. And they're typically used to store multiple data types like documents, spreadsheets, and presentations inside of a single file. And it's very handy for extracting and examining the contents of these types of files. So this is where oldump.py actually comes in, very useful. And it's very often used for forensic analysis and digital forensics and malware detection. So you can use it, but if you're actually inside of the TryHackMe room here, you can use it by navigating to this specific location, and the target file that we're going to be analyzing is the agent tesla.xlsm, and we're going to run this specific command. So this is what it looks like if you run the command, and this is the example output that you would get. Based on the analysis, a VBA script might be embedded in the document and found inside this specific path. Therefore, oldump will assign this with an index of A, and it can sometimes differ, obviously. So A index is plus the numbers are what we call the data stream. So this is the location, and then we have the number associated with the things inside of this location. So these would be potential data streams. We should be aware that the data stream with the capital letter M, this means that there's a macro and you might want to check out that specific data stream. So this one right here is the one that has a capital M, and a macro is what can be embedded into the macro data, the metadata of the file. And you can find it in this particular location, right? So we can check it out and run the command oldump.py against that, and then do the S4. And it'll run the data stream that is relevant to number 4, which is this piece right here. So you do S4 for stream 4, and the S parameter is short for select, and the number 4 would be the data number 4. So, and that's the one that actually has the macros in it. So if we run that right here, this is what the command actually would look like, and then this is what the results would look like. So we have all of this hexadecimal and binary data, and then we have this ASCII base 64 encoded portion right here on the side. And what do we have? So let's see, there's some, you can technically kind of read some things inside of it, although most of it seems jargon because of the way that it's been formatted. There seems to be some kind of an IP address in here. There's a PDF document extension. There's a script for shell that has ran. So based on the results above, we have the hexadecimal dump format. There might be some familiar words with a trained eye. However, this is still challenging for us because technically we are in CySec 101. So let's make it more readable. And so we can run additional parameters, which is the VBAD-E compress or VBA decompress. VBAD-E. So VBA decompress. When we use this, oldump will automatically decompress any compressed VBA macros it finds in a more readable format. So this is what the command would look like: oldump, and then the file itself, we're selecting the 4, and then we're going to use VBA decompress at the end of it, or VBAD decompress. That's hilarious. And then this is what the results would be. So it would say this is the name for this, the base encoding for it. Global namespace doesn't have any. Creatable, no. Pre-declared ID is true. Exposed is false. Template drive is false. It is customizable. Private sub workbook open. What else do we have over here that might be interesting? The SQT new seems to have a bunch of stuff in it. So Windows or Windows style hidden, execution policy, bypass, temp file, get temp file, rename item, new name, replace temp executable, pass through, invoke web request. The URI is this location, and then this is the document executable is downloading from that location. Out file, which is going to be the output, is going to be that temp file, and then start the process. So that's the full command that we can kind of decipher from that whole thing over there. So now we don't need to be able to read the whole script, but we can familiarize ourselves with some characters and commands. And our interest here would be the value of sqt new, which is what we just analyzed. There's a public IP, PDF, executable. And if you look at it further, again, they're kind of doing the whole thing, but we just looked at that whole thing. So you can copy the value of this and paste it into CyberChef's input area, and you can open a local copy of it either inside of Remnux, or you can go to the link for CyberChef, which you literally can just Google CyberChef, and it's the very first link that pops up. And so when you put the entire value of that inside of this, and the recipe that they're using here is the find replace recipe with two different find replaces. So they're taking the find and replace, and they're replacing all of the asterisks with nothing, so with an empty location, and they're taking all of the kind of these like up arrows that we see also with nothing. So it essentially just removes all the asterisks and all of the up arrows, and then it turns it into this full command that you see right here, which is the clean version of that command. And inside of that, this is all the stuff that we actually have over here, right? This is the full script that was available to us. And things like invoke web request is a PowerShell commandlet that invokes a web request. It actually goes to the internet and pulls something from this specific IP address and downloads this executable file. It downloads it to this temp file location, and it starts the process, the temp file. So it does all of these things and then does it in a hidden window, because you don't want the window to actually pop up. So if anybody's logged into the computer, it can see that there's something going on. So it actually happens in the background, and then it does all of these things, which is very, very sneaky stuff, really. So the window style parameter allows you to control how the PowerShell window appears when executing command. In this case, hidden means that it won't be visible to the user. By default, PowerShell restricts script execution for security reasons. The execution policy parameter allows you to override this, and the bypass means that the execution policy is temporarily ignored, allowing any script to run without restriction. Invoke web request is commonly used for downloading files from the internet. URI is the URL that we're going to download. In this case, they're downloading this specific script from that specific IP address. And the out file specifies the local file where the downloaded file, downloaded content will be saved. In this case, the executable will be saved to temp file. And the start process is used to actually execute that download, which is this temp file variable that we have that is storing this executable. So when the document agent tesla.xlsm is opened, that macro will run, which is this command. This full command that you see right here is embedded inside of the macros of this. So if you open this, the macro will run, and it contains a VBA script, and it will run a PowerShell to download that file and then execute it. And that is, I mean, presumably it's not a good thing that's going to happen. So here are our first series of questions. So what Python tool analyzes OL2 files? So this was it was the old dump, right? Is that what it's called? Old dump, yeah. So old dump.py is the file that downloads that. Oh, it's not even typing. So old dump.py, there we go. What tool parameter we use in this task to allow you to select a particular data stream? So that would be the S parameter. During the analysis, we were able to decode a PowerShell script. What command is used for downloading files? So that would be invoke web request. And what file was being downloaded using the PowerShell script, which is this thing right here. So let's just highlight that guy and go over there and embed that over there. During the analysis of the PowerShell script, we noticed that a file would be downloaded. Where will the file being stored downloaded? So this is going to be the temp file. That's what we have. And using the tool, scan another file named possible malicious doc located in this directory. How many data streams were present? Using the tool, scan another file, possible malicious doc located in the, okay. At what data stream does the tool indicate a macro present? So now we actually get to run this tool, which is exciting. So now we actually get to run it, which I'm very, very excited about. So first we need to go to this location. So what do we have? We're going to go cd home ubuntu desktop tasks agent Tesla. All right, and there it is. So let's do a list here. And we do have agent Tesla XLSM, and then we have possible malicious doc. So now we're going to do old dump.py, and then we're going to do possible underscore malicious dot doc x, like that. Just like that. Boom. And now it's going to run. And then let's see what data we can get. Oh, that was pretty quick. There we go. Good stuff, good stuff. All right, so select stream 8. This stream 8 right here has the capital M next to it that actually has macros. And so it's selection number 8, which is the one that has the macros. And then how many data streams were present? 16 data streams are present. And there we go. Now we actually ran old dump. This is actually very, very cool. I love this so much. It makes it so easy to analyze any given file to see what's in it. I love this freaking distribution of Linux. That's amazing. Remnux. Okay, cool. All right, so now we can do a fake network to aid our analysis. Let's do that. So the opposite of static analysis would be dynamic analysis. And in static analysis, we're just looking at something without running it, without opening it. When you do dynamic analysis, you actually run the thing, or you open the file, you run the software, whatever the activity is, you actually do the activity. And so what we're doing in this case is we're doing it to observe the behavior of whatever that potentially malicious item is, especially what it's going to do inside of the network. So there are a lot of ways that obviously you could do this. You can create an entire infrastructure, a virtual environment with different core machines and more. And there's also a tool inside of Remnux VM called the INetSim, which is the Internet Services Simulation Suite. And we can use this to simulate a network, right? So for this, we're going to use two machines. The first is the Remnux machine, which is linked to the machine access. And the second is the attack box. And so I have to start the attack box real quick. So while that starts, I'm going to read the rest of these instructions that we have over here. So do note that you can easily switch between the boxes by clicking on them, which is okay, that's fine. So before we start, we must configure the tool INetSim inside of Remnux. Don't worry, this is a simple change configuration. First, change the IP address assigned to your machine, and this can be seen using the command ifconfig. And then for running that from the terminal, which I'm assuming is going to be the terminal for my Remnux machine, or is it the terminal for the attack box? Okay, I believe this is the IP address for the Remnux virtual machine. It's not the IP address for the attack box. So it actually even says it over here. Every time that you load one of these machines, or when you load a room, these IP addresses get updated in real time. If I had not loaded the virtual machine, this would just say IP address over here. So that's the IP address for our virtual machine on Remnux. We need to change the INetSim configuration by running sudo nano and then going into the configuration file, which is located in the configurations directory. So the etc directory holds all of the configuration files. And then, of course, when you go inside of the folder for any given software, it has the declared or the dedicated configuration files for that software. So when we open this configuration file, you have a path, which is the default IP, which is right here, DNS default IP. So you got to remove this hashtag to uncomment it. And then we'll go ahead and, oh, it's actually right here, excuse me. So we got to remove the hashtag to uncomment it, and then we'll go ahead and modify it so that we can actually update the IP address for our virtual machine to the DNS default IP. So it actually says it right here. So remove the comment and then change the value of DNS default IP from the 000 to the IP address, which is this thing right here. Save the file and then move on. So confirm the changes by just running the cat command, which is this piece right here. So we're going to cat, and then we're concatenating the contents of the configuration file. And then what we're doing with this portion is that we're grepping, meaning we're searching for this specific value so that we can pull that line from the file. So when you do that, it actually pulls it and it just shows you that the update was made. Then we are going to run the INetSim, And now that it has its new configuration, it will run with that configuration. And so when you run it, it basically, I mean, it's literally a very simple command to actually run it. And in that case, it'll start the simulated environment for you. So simulation is running by the end of it. You can see that at the bottom of the result, and ignore the HTTP 80 TCP failed, which is where right here, this piece right here. So it says ignore that, and then now we can go to the attack box and then go to the IP address, which is located right here, and it'll say security risk, ignore, click advance, and then accept. And so once you do that, you will end up in a page like this. This is the default HTML page for INET SIM. This file is an HTML document. One usual malware behavior is downloading another binary or script. We'll try to mimic this behavior by getting another file from INET SIM. We can do this via the CLI or browser, but let's use the CLI to make it more realistic. We're going to use this command. So wget is essentially the Linux version of invoke web request, where it downloads a given file. So we would be downloading the second payload.zip, and then no check certificate because it doesn't have a certificate. So we're just saying don't check the certificate because it would give us some kind of a security error if we did that, or if we didn't do that, excuse me. So when you actually run it, then it's going to connect to the thing, and then it's going to invoke the web request, and it's actually going to download it. So wget is very similar to invoking web request, and it'll just download whatever the file is. So you can now try downloading another file. So we can do wget and then do second payload.ps1. So we had the zip file, but then you can also just download the ps1, which is the extension for a PowerShell script. And same thing, right? You would do no check certificate, and then it just downloads the files for you. So they're fake files. If you open the ps1, when we execute it, this will direct you to INET SIM's homepage. What we did here is mimic a malware behavior wherein we try to reach out to a server or URL and then download a secondary file that may contain another malware. So the report would be written to this location for INET SIM, and reading it would be very similar to what we did previously when we were trying to read the configuration file. You just use the cat command, and it'll display everything onto the screen, and it is most likely going to look different for us when we actually run it. But this is the full-on logs, basically. These are like all of the events that happened that INET SIM was actually logging. So first simulated date in log file, then the connection method, and then get these various files, right? So we did the payload ps1, payload zip, all of those things is what we did. These are the logs where the tool was running, and you can see that the connection is made to the URL, the protocol, and the method that it's using. And you can also see the fake files that were downloaded. So download and scan the file named flag.txt from the terminal using this. No check what is the flag, and then after stopping down at some read to generate a report based on the report, what URL method was used to get the file. I'm just going to say that this is a get method because that's usually what you do to get a file when you're using an HTTP method. So that was the easy one, that was the gimme, but we need to go ahead and get that flag. So first, let me go to my Remnux, and what I'm going to do is I'm going to modify the configuration file. It may have already been, I don't think it has been, because the IP address would be issued new every single time. So what I need to do is I need to first go ahead and modify that file. So I will go to my root real quick, and we'll make sure that we're there. What are we doing? All right, cool. We'll clear our screen. So we're going to do sudo nano, and then we're going to open up the INET SIM configuration file, and there it is. So if we open this thing, and what's my IP address? It is 10.10.247.226. Okay, cool. So we need to find that specific location, right, that has the let's see, 1,931 lines. How crazy is that? So we need the one that says DNS something something, and it has an IP address of 000. So that's the server's bind address. Let's see. Okay, there we go. So DNS default IP. Now, I think there's also a way that I could have made this a little bit easier. So if I do a search and I go for DNS default IP and then click that button, there we go, DNS, it automatically finds it for you. So that would be probably an easier way instead of manually scrolling through everything. So there you go, and then we're going to delete that hashtag to uncomment this location, and then we're going to delete this piece, and then I'm going to paste it in here. So let's see if that works. It does not work. So I will have to manually type 10, 10, 247, 226. Great. Now Control O, and it's going to say the file name that you want to write. Is that fine? Yes. Press enter, and then Control X, and now we're done. So now we're going to do cat, and then etc inetsim /inetsim.configuration, and then we need to grep for the DNS. What was the key that I'm grepping for here? It's the DNS default IP, enter, and there we go. We actually got the IP address changed. So that is all good. So, okay, cool. The configuration file is all good. So now what I need to do is I need to go ahead and actually run the inetsim. So we will do sudo inetsim enter. And let's give it a quick second. And we got the same error messages and everything else. Now it says simulation running. So perfect. All right, cool. So we got that. So now we're going to go to the attack box at the bottom right here by clicking the attack box. And you can essentially, if you have like a Kali Linux machine, you can have your own machine be your attack box. You just need to be able to, if you're doing this in your own environment on one machine, you need to have your inetsim that's running. And then on your secondary machine, you would have your web browser that you would go to try to simulate the connection to that that web server, or that overall simulation environment that you've created. So for me, it is the https //10.10.247.226. We're going to get a potential security. So we're going to go click on advanced here. And then we're going to say, I want to accept the risk and continue. And cool. So this is the default HTML page. All right, cool. So there's that. So now I'm going to open up a terminal inside of my attack box here. And what I'm going to do is I'm going to download this file that they tell us to download at the bottom right there, which is that flag. So sudo wget flag. So let me see. It's sudo wget and then https //10.10. Whoops. 247.226 and then /flag.txt -- no-check no and certificate. There we go. And cool. So we got it. So that's the link that I was supposed to go to. And then I did no check certificate because it doesn't have a valid certificate. So we don't want to check it. And we got a downloaded flag file. So we're going to do ls here. And there is indeed the flag file. So let's clear the screen and we're going to do flag.txt here. And this is the default text document, and here's the flag. TryHackMe Remnux edition. So copy that. Go over here, paste that. That's the flag. And the get request, I kind of guessed, but what we can do now is we can go to the Remnux machine that we have over here. And we are going to stop it from running. So I can just do Control-C most likely. And there we go. So the simulation has been stopped and it's all good. And now the report was written to this location. So we're just going to copy that and we'll do cat and then we will paste that location here and press enter. And let's see, permission denied. Oh, I'm supposed to do sudo cat. Got it. Sudo cat. That sounds like a band name. Cool. All right. So sudo cat. And these are the contents. So first simulated HTTPS method get. So you see that there's a get method for the URL. And then it has the file name sample HTML, get URL file name sample favicon, and then get URL file name sample text. And where's my flag? I thought it was, oh, flag.txt. There we go. That's where it is. So right there. So this is the URL for the flag.txt, and then this is the URL for favicon. And that's it. So that is our report that we were able to pull, and it confirmed exactly what I had already figured out, which is the get command. So we are good to go. Now we can go into the memory investigation, evidence pre-processing portion. In the context of digital forensics, when we're talking about memory, we're always talking about the RAM memory, the random access memory, which is considered to be volatile memory. And the reason why it's volatile is if the machine is accidentally powered off or restarted, or you lose power and the machine turns off, anything that's been stored inside of that memory is going to be wiped. So it is more important to pull information and to pull artifacts and data from the memory, from the volatile memory, than it is to pull it from the disk image, because the disk image, all the stuff that's been stored on the actual hard drive, isn't going to be wiped if you restart the computer, but the stuff that is stored in the random access memory is going to be wiped. So this is one of the big things that has to do with digital forensics. You always want to go after the volatile memory first. And so there's a tool called volatility that actually deals with getting memory images as evidence, which is a very powerful tool. And the reason why you do this is that a lot of times one of the common practices is to get that pre-processing, meaning download all of that stuff that's inside the memory, save it inside of a text or a JSON format type of a file, because more likely if it's like a desktop that's on the crime scene, then you have to turn the desktop off to transfer it to your evidence locker. And before you can do that, you need to take whatever you can from the memory images so that you don't lose that random access memory, because you have to turn off the computer, right? So that's the thing where volatility becomes very, very useful for. And volatility is pre-installed inside of Remnux, which is very, very useful. So the commands for volatility are executed to identify and extract specific artifacts from memory images, and the resulting output can be saved to text files for further examination. We can also run a script involving the tool's different parameters to pre-process the acquired evidence faster. Pre-processing volatility is one of the things that we are going to learn, because I actually don't even know how to do it, so we're going to do it together. So we're going to use the Volatility 3 tool version. However, we won't go deep into the investigation and analysis part of it. We just need to grab the evidence. So we can write a whole book about the analysis of evidence. Honestly, it's an entire world all by itself. And if you go into digital forensics and incident response, more likely digital forensics, if you go into digital forensics, you're going to do very well, because you can work for the FBI, you can work for the police department, the government, and they pay fairly well. If you work for a private company, you'll probably get paid more than you would if you work for the government. But all in all, it's a pretty cool gig. And of course, you're dealing with crime scenes, and it's pretty cool stuff. So we want to be familiar with and get a feel for how the tool works. So we're going to run the commands as instructed. And each plugin takes 2 to 3 minutes to show the output. These are some of the parameters or plugins that we're going to end up using. And we're going to be focusing on the Windows series, which is all of this stuff. So the PS tree, PS list, CMD line, file scan, DLL list, malfind, and PS scan. Notice that each one of these has Windows, PS tree, and then there's a capitalized P and a capitalized T like that. And for each one of them, it's literally the same thing. So within this module, there is the PS tree utility itself, right? Or the plugin, excuse me. So we are going to run sudo su to actually switch to the user. And then we're going to navigate to this location, and the file would be wcry-mem. And we will run each plugin after the command vol3 file wcry-mem. So this would be the full command right here, for example, to run PS tree. So vol3 file would be wcry-mem, and then windows.pstree.pstree like that. And then it will do the scanning, etc. And so you would get results as such. And then PS list, same thing, and then you get results as such. And then command line, same thing, and you get all of the command line executions that happen. File scan, same thing, you get all of the files that would be available. Long list of files. Holy cow, look at that, that's insane. Okay, let's scroll more. Man, that is a large output, yo. That's insane. Okay, and then we have DLL list, and there's no output for that, thankfully. PS scan, let's see the output for this. Is there a long output? No. Okay, cool. Malfind, and that's pretty much it. Okay, so potentially malicious documents would also be scanned using Malfind. So for more information regarding all the plugins, we can actually go to the link for Volatility and look at the plugins package on their website, which is a pretty in-depth and comprehensive list of plugins that are available. There's also a volatility video that's on this channel that you can go check out. It's part of the Digital Forensics Incident Response playlist. You can also just search for volatility and you'll be able to find that. I think there's actually like 2 or 3 videos on volatility. So now that we have the plugins running individually, we can see the results. What we do now is process this in bulk. So one of the investigative practices involves pre-processing evidence and saving the results to text files. And the question will be, how do you do that? We're going to create a loop statement. So it's going to be like this. For loops are very, very powerful for automation. So it says for plugin in windows.malfind, windows.psscan, windows ps3. So for the plugin in that list of plugins, semicolon, do this, where you actually go ahead and run the command, and then you run the plugin variable, and then you output all of that into the wcry.plugin.txt, and done. So what this is going to do, it's a very, very simple command, but it's extremely powerful. So we first create a variable called plugin. So when you say for text in whatever, this piece right here, whatever this name is, it could be for plugin, it could be for random, and whatever you decide to use as your variable in this instance, this is going to be turned into an official variable that you can use for shell scripting. The variables are referred to by putting a $ in front of whatever this word is. So in the first instance of it, we're just going to say the word, but then at the very end, when you refer to the variable, you are putting a $ in front of it because you are referring to everything inside of this list right here, right? So for plugin in Windows, and then what you can also do is you can say, you can create a variable called plugins. So you could say plugins equals, and then give it all of these items, and all of those items are going to be stored inside of the variable plugins. So you would say for plugin in plugins, and then you would do the $ plugins as a reference to pull all of this stuff that you've stored in it, and then you would do the rest of the stuff, right? So we then ran the vol3 parameters in quiet, which means quiet mode or doesn't show the progress in the terminal. F, which means the read from the memory capture, and then the plugin into this would be the running it and outputting to a file at the beginning of the text following the name plugins with an extension of txt, and this would repeat until the value of plugin is fully used up. So it would actually create a new file for each one of those elements. So it would say Windows CMD line, Windows DLL, Windows file scan. It would create a text file for every single one of those, because that's literally what the script says to do. Very, very powerful script, very useful, honestly, in automation, and it's pretty amazing, honestly. So, excuse me, I keep hiccuping. We're going to pre-process the memory image with Linux strings utility, and we'll extract the ASCII 16-bit little endian and 16-bit big endian strings, and these are what the commands for those would be. So it would be strings wcry mem, and then ASCII, strings ELEB wcry mem, and then it would output to the Unicode little, Unicode big, and then there you go. That's how you pre-process the memory. And the strings command extracts the printable ASCII text, which is the EL option telling, the string command extracts the printable ASCII text, and then the EL option tells it to be little endian, EB tells it to be big endian, and all these formats will provide useful information about the system under investigation, and that's it for that. I think we're going to end up running it, but that is the instructions for how to run it. So what plugin lists processes in a tree based on their parent process ID, and that would be the tree. So let's actually go to the list of the plugins that we have at the very, oh my god, I totally forgot about this. I need to hide this because it's a massive freaking list. Okay, so it's PS tree. When I tell you that it took like a good 30 seconds to get past that list of stuff, I am not exaggerating. It was a long list. What plugin is used to list all currently active processes in the machine? So we go up here. This will be for processes present in a particular memory image would be ps scan. DLL list would be the memory image. What else do we have? File scan, cmd line. PS list is to list all the currently, okay, so PS list is for the active processes. PS tree would list everything based on their process ID. So PS list is for active. What Linux utility tool can extract the ASCII 16-bit and all of that, which is the very last thing that we had over here, which is our strings. So that's the strings tool. By running vol3 with the malfind parameter, what is the first process identified suspected of having an injected code? So if we go, let's see if it's the one that they're referring to when they actually ran malfind themselves, because they did run it over here. But there is no output for this though, so I wonder what I'm supposed to be. Is there a file that I'm supposed to scan? So let me see. Yes, so this was actually the file, which is the wcry-mem. Obviously we actually have it available in our lab. So first we have to do sudo su to switch the user. So we'll just do that. And there we go. Now we are officially root. And so what we're going to do is we're going to go to that location real quick. So I'm going to cd home ubuntu desktop tasks and then wcry memory image. There we go. And so in here there should be a wcry mem file, and there it is. So we're going to do vol3, and then we're going to do fwcry.mem, and then we're going to do the malfind command, which was the one right here. So it is windows.malfind.malfind with a capital M. And there we go. So that's the command. Let's give it a couple of seconds. Let's see how long it takes. All right, so there it is. Okay, so the very first file is actually csrss.exe, and then we had multiple instances of winlog or winlogon.exe, but the very first one is the what is it, csrss.exe. So that's the one. That would be the one right here, csrss.exe. Very good. Cool. Continuing from the previous question, what is the second process identified from having the injection code? So that was the winlogon, which is this piece right here. So we will do winlogon.exe. And by running the vol3 with the DLL list parameter, what is the file path or directory of the binary wanna decryptor at.exe? So I'm guessing they have not done it for us, because there was a few of them that didn't have an output. So malfind, pscan, DLL list. Yeah, so DLL list doesn't have an output either. So we're going to run the whole thing, and then we're going to do it with the Windows DLL list on wcry. So let's just go over here. We will do vol3 fwcry.mem, and then it's going to be the DLL. No, excuse me. Windows.dll. Not DLL, it's DLL list.dll list. Enter. There you go. So you need to have a DLL list, all lowercase, and then capital DLL, capital L list. And there we go. So the question says what? It says, what is the file path or directory of the binary WannaCry decryptor? Okay, so this is what I need to do. I'm going to run that one more time. And I'm going to grep for WannaCry because I don't want to search through this. So I'm going to run exact command. I'm going to pipe it into the grep, and then we will do at wanna decryptor at.exe like that. So we ran the full command. So this is the vol3 wcry and then we're going to pipe it into the grep command to search for that. And then we're going to search for that, and let's run it. Boom, and it only brought up that result for us. So the path that we're looking for is this thing. So it starts with the C and it goes all the way over here, right there. That's the full path. So we're going to take that and boom, enter. Right, so they actually don't want the last portion. They don't want this WannaCry portion. So it's going to go all the way to this IVQ man perk whatever 615. That's where it ends right there. So that's the answer for that. And that's it, my dear friends. We are officially done with the commands on Remnux. Let me tell you, this is a very, very powerful distribution. I already love this. I think if Kali Linux is for pen testing, Remnux is for defensive security. Up until now, Kali Linux was definitely my favorite distribution, and I think it still is my favorite distribution of Linux because I enjoy pen testing and ethical hacking. But for defensive security, I don't think there's anything that comes even close to this, because the tools, excuse me again, I apologize. I feel like that's very disgusting. The tools that are inside of this are super freaking useful. I mean, the very, very first one that we used, which was the file analysis tool, which was OldDump, that was just unbelievable. The ability to be able to scan a file for macros is a really big deal. It may seem super simplistic, but it's extremely powerful. Very similar to that script that we ran where it's like for all of these things inside of this list, do this. That was like very, very basic script, and it will create all of these pre-processed files for you. And that's, again, a very powerful, very, very powerful little tactic that if you just do that, it ends up saving you time, energy, and it ends up doing just so many things for you. It's unbelievable. Very, very powerful stuff. And then you can output everything into its own given file, and just really freaking cool stuff. So I love that extremely. And I think that right next to Kali Linux, or maybe right underneath Kali Linux, Remnux would be the one which would be my second favorite distribution for Linux. And that's exactly what we used in this particular video. So now we can go ahead and click complete, and we are officially done. We got a chance to simulate a network for a sandbox environment. We got a chance to extract stuff from files. We got a chance to run these various evidence for memory investigation from volatility. Very, very cool set of exercises that we just ran in this video. It was less than an hour, and I think it was very useful, very impactful. It's interesting. It's like the end of the CySec 101 training series is actually teaching me some really, really good stuff that I think is, again, I just think it's very useful. I don't want to overhype it, but it's genuinely very useful. So yeah, that's it. You're officially dismissed. I just got to make a couple of final notes and you're out of here. If you found this video useful and you would like to get more videos like this, including the ones in the CySec 101 playlist, I do encourage you to like, subscribe, and turn on the notification bell. And of course, drop a comment if you have any questions about what we talked about today, or if you have questions about any other topic. Definitely go make sure that you check out all the content on the channel. So for example, the stuff that I was talking about with CyberChef, it's actually on the channel. It's one of the most recent videos that was posted. There's a lot of really useful playlists that are available, like the CySec 101, Security Plus, Linux Plus, SOC Level 1, SOC Level 2. There's Network Plus that recently got uploaded as well that I need to just update on this playlist section that we have over here. There's a lot of great content that's on the channel, and there's a lot of great content that's coming out in the near future. So if you'd like to get notified of that, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. If you're serious about your CySec training and want to get access to me on Discord, consider joining the Hackaholics Anonymous membership community. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there. Or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later. In episode 51 of the CySec 101 training series, we're going to go through the Flare VM, the Flare virtual machine, which has an arsenal of tools for investigation. So this is more for digital forensics than anything else, and for investigative security than anything else. And of course, this is a part of the defensive security tooling module in the CySec 101 pathway of TryHackMe, and it happens to be the very last room which is basically like the last practical kind of informative room when it comes down to techniques and tools that we're going to be using. And then right after that, we're going to just go into the last couple of modules for security principles and the training impact on teams. And that's basically it. We're going to end up wrapping up Cybersecurity 101, which is something that I'm actually very excited about. As a part of this specific video, we're going to go through the introduction for Flare VM. We're going to look at the various arsenal of tools, commonly used tools for investigations, the overview, analyzing an actual malicious file or files, and we're going to go through the conclusion, and I'm going to give you a little bit of a couple of final notes, and you will be dismissed for the day. And that's pretty much it. I'm really excited about this one. This is another one of those tools that I did not get a chance to check out yet, so I'm pretty stoked to share it with you. If you're serious about your CySec training and want to get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master, and each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, bug bounties, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Flare VM room. The Flare in Flare VM stands for Forensics, Logic Analysis, and Reverse Engineering, and it's a comprehensive and carefully curated collection of specialized tools uniquely designed to meet the specific needs of reverse engineers, malware analysts, incident responders, forensics investigators, and penetration testers. So this is a pretty robust series of tools, or arsenal, I guess I should say. This toolkit, expertly crafted by the Flare team at FireEye, is a powerful aid in unraveling digital mysteries, gaining insight into malware behavior, and delving into complex details within executables. So very, very comprehensive list of tools, it seems like. The objective for this video is to explore the tools inside of Flare VM, to learn how to use the tools to analyze potentially malicious processes effectively, and be familiar with the tools that are used for static analysis of malicious documents and binaries. So it's kind of similar to what we went through when we were looking at the series of tools that was available inside of, I want to say, Remnux. It was like a few of the things that were available inside of Remnux. But I think there's more inside of Flare VM. This room expects you that you're familiar with the technical terms related to Windows and processes. If you're unfamiliar with these, go through the pre-security path, which we've already done. So you should be very familiar with these things. Hopefully, I hope you are. But if not, I'll still do like a good glaze over some of these things just in case you're not familiar with them. And then if you want, you can do some independent research to learn about them. I've already launched my virtual machine, which is a part of the TryHackMe subscription that I have, but you can always get your own version or get your own installation of Flare VM and go through these things alongside with me. Flare VM, I believe, is free. So let's see if we can do Flare VM download and see what we can get. Flare VM is a collection of software installations. It's available through GitHub, so it is actually free, and it's something that you can definitely use on your computer as well. So there is that. Almost all the files that we will be using is inside of our location for this room. The disclaimer here is that this contains malicious example files as part of the practical exercises and has no internet access. They should not be downloaded, executed outside of the Flare VM machine, or distributed under any circumstances. Doing so could potentially harm your system or network. Always handle files only in isolated, controlled, and secured environments. That's actually a very good note to give us, and I'm glad they gave us that. I wasn't going to download these anyways, but I'm glad they told us that. Okay, cool. So let's move on to the official arsenal of tools, excuse me, inside of Flare VM. The tools inside of Flare VM have several categories that they fall under. We have the reverse engineering and debugging, and so it's Hydra, I believe that's how you pronounce it, Hydra or Hydra maybe, but I want to say Hydra. It's developed by the NSA, and it's open source reverse engineering suite. We have x64DBG, which is open source for binaries in x64 and x32 architectures. We have OllyDBG for reverse engineering at the assembly level. We have Radar, or Rawdare, a sophisticated open source for reverse engineering, Binary Ninja, disassembling and decompiling binaries, and PEID, a packer, crypter, and compiler detection tool. Then we have the disassemblers and decompilers, the CFF Explorer, Hopper, Disassembler, and RetTech. And CFF is designed to analyze and edit portable executables. Hopper is a debugger, disassembler, and decompiler, and RetTech is an open source decompiler for machine code. And of course, we have static and dynamic analysis. No toolkit would be complete without static and dynamic analysis tools. So obviously, Flare VM also has them. Static is when you look at the code of the tool, or you look at the tool itself without actually running it. And dynamic is when you run it and you look at how it behaves and what it does, what methods it executes, as it goes through its run. So static, as the name implies, is static. It's stationary. We're not doing anything. We're not running it. Dynamic, as the name implies, is that essentially it's like a dynamic, spontaneous kind of an environment. You're running the tool to see how it works. So we have the process hacker, which is sophisticated memory editor and process watcher. We have PEView, portable executable file viewer for analysis, dependency walker for displaying and executables DLL dependencies, and then DIE, oh my god, detected easy, a packer, compiler, and crypter detection tool. Then we have forensics and incident response. And so incident response is more of a live type of an environment. As an incident is happening, you want to respond to it as best as you can. Forensics is more so after the fact, when you do some kind of an investigation and you're trying to track or reverse engineer what happened. So we have volatility, which we used in the last video, and this is for the volatile memory, which is memory that can be wiped if you restart the computer or if the computer accidentally shuts down. So it's stored inside of the RAM. So anytime that we refer to memory in these contexts of conversations, we're not talking about the hard drive or the storage memory. We're talking about the random access memory, the volatile memory that can be wiped if you restart the computer. So volatility is one of the key tools for that. Then we have recall for memory forensics and incident response. And then we have FTK Imager, which is a really popular one, stands for Forensic Toolkit. And it's an imager that takes images of the disk and helps you analyze them as well. Of course, we have network analysis, so Wireshark, Nmap, and NCAT. There are multiple videos on this channel for every single one of these tools. These are very, very common tools when it comes down to network analysis. File analysis would be File Insight for looking through the and editing binary files. We have HexFiend, the hex editor, and we have HXD, which is for file viewing of binary files and editing within a hex editor. Scripting and automation, of course, Python, of course, PowerShell. Python is one of my favorite, if not my favorite language when it comes down to automation. There are multiple videos on this channel for Python, including a Python for cybersecurity video that is all inclusive. It goes from the very beginner, which is, downloading and installing Python, downloading your favorite IDE, which is PyCharm for me, and then creating your very first program, learning about functions, variables, lists, dictionaries, etc., and then working your way all the way up to building your very first algorithm for cybersecurity. So pretty intensive and comprehensive video is the Python for cybersecurity video on this channel. So check that out if you have not checked it out already. And of course, PowerShell, because it's a Windows framework and it's very, very powerful, no pun intended. Then we have the SysInternals suite. And this is utilizing to help IT professionals and developers manage, troubleshoot, and diagnose Windows systems. So SysInternals is dedicated to Windows operating systems. So auto runs, which is what executables are configured to run during system boot up, Process Explorer, and Process Monitor, which are the running processes as well as processes that can be monitored and logged in real time. And then there's of course, I would say there's probably more inside of Flare VM. I think these are like the most common ones, but even this is a pretty comprehensive list of software and tools that are available. So a very, very, very robust operating system or virtual machine that, that's pretty solid, dude. Honestly, when you think about it, it's pretty darn solid. So there's a lot, right? We're going to tackle all these tools, or we're not going to tackle all these tools right now because it could take months to finish, because each one of them, you can have an entire training series just dedicated to each one of these tools one by one. Literally, you can have an entire training series, an entire class dedicated to Python. And I'm talking about like a college class. There are people that specialize in Python, and there are so many things that you can learn just about Python, or just about PowerShell, or just about, Nmap, whatever it is. There's just a lot that you could do. So we're not going to go through all of them, but we will be looking at some of the most common ones and the more standard ones for investigation. So which tool is an open source debugger for binaries in x64 and x32? And so this is what I always do, just to kind of cheat it. If there's a lot of content, I will just copy it and I will search through the page for that. So it's going to be the x64 dbg, and then we will click back and then go back to the question and then paste it in here, and there's the answer. So what tool is designed to analyze and edit portable executable files? So we'll do this, and then we will copy, find, and then go through the course. And then so there's 3 references to it, and CFF Explorer is the one designed to analyze and edit portable executable files. So we'll go back again. So it's kind of a cheat, but I mean, I'm a hacker, you know what I mean? Like, you have to find hacks even as you go through the studies, which is considered a sophisticated memory editor and process watcher. So that's the one that I probably need to go a little bit through. So let's see if we can search for process watcher, see if we find anything. Oh, and indeed there is a second option. So let's see what the second one is. And that is the process hacker. Look at that. A hacker for the hacker. You gotta love it. You got to love it. Which tool is designed for disk image acquisition? And this one I know for a fact. So it is the forensic toolkit. No. Oh, it's not. So disk image acquisition and analysis for forensic use. I really thought that it was the FTK toolkit. So forensic toolkit, is that not it? What is it? Oh, FTK Imager. That's what it is. FTK Imager. Okay, I got it. I was pretty close. So FTK Forensic Toolkit Imager. That's what it is. What tool can be used to view and edit a binary file? And then, of course, we're going to run through that. There's actually multiple, but this is the one. HXD is the one that shows up for that. So that is our very last question. I mean, I do that fairly. If there's a lot of content that I have to sift and sort through, that's kind of my approach to try to find it. And when you know how to reference these things, when you know how to do research, that's like one of the big skills that comes with anything in tech in general. You just have to learn how to research to try to find the thing that you really need. And searching through a massive document using the control find or command find, or maybe Python, or maybe CyberChef or something like that. These are some of the key skills that you need to learn how to do if you want to do things quickly. Okay, so just giving you a little bit of a tip right there. It's kind of like a learning hack, an educational hack. All right, so let's look at the commonly used tools for investigation. These specific tools are used for initial investigations. So we have the procmon, which is the process monitor for tracking system activity, like malware research, troubleshooting, and forensic investigations. We have process explorer to see the process of the parent-child relationship, the DLLs, the dynamic link libraries that are loaded, and the paths associated with them. We have HXD, the malicious files that can be examined or altered via hex editing. Wireshark for network sniffing and network traffic. Very, very powerful tool. We use that a lot as well. There's, I would say, probably at least 5 videos on Wireshark on this channel. We have the CFF Explorer, which can generate file hashes for integrity verification, authenticate the source of a system file, and validate their validity. We have PE Studio, the static analysis or studying executable file properties without actually running the file. And then we have Floss, which extracts and deobfuscates all strings from malware programs using advanced static analysis techniques. So we can follow along and open them on Flare VM while we discuss the overview of some of these things. So I'm going to go through the screenshots, and if we do need to launch them for the actual questions that we need to answer, then I'll go ahead and launch them. But for the most part, we're just going to follow along with the documentation and the notes. And if we need to pull anything, we will. So this is the process monitor, also known as Procmon, and it's a Windows tool that's designed to help you record issues with your system's apps. It lets you see, record, and keep track of system and Windows file activity in real time, and is helpful for tracking system activity, especially regarding malware research, troubleshooting, and forensic investigation. It keeps real-time tabs on the file system registry and thread process activity. So when we look at the screenshot, this is what we got. So these are, each line item presents a given event that's taking place, right? So the time of the day that it took place, the process ID, the operation that was ran using that process ID, the path of it, whether or not it was a success or a failure, and the details of it. So non-cached or I keep saying cache until somebody corrected me. So I guess that's supposed to be non-cached, which still feels kind of odd to me. But so these are the examples in this particular case, right? So this is for the process monitor. So according to this entry, according to the entries that we have above us in that screenshot, the Local Security Authority Subsystem Service, which is LSAS, related to the process LSAS exe, has successfully read a file. So you can see the operation was read file, right? It handles authentication and frequently communicates with crucial system files such as the LASRV, the Local Security Authority Service server service. Although this is a standard process, LSAS may be the target of credential dumping attacks if you're examining logs for indications of malicious activity. Mimikatz and other tools frequently try to access the LSAS memory. In these situations, you should watch for any additional suspicious activity related to LSAS, which as odd access patterns or processes reading or writing to LSAS. So these are not going to show any malware signs in case you actually want to run them. Then we have the Process Explorer. It offers in-depth insights into the active processes running on the computer. It allows us to delve deeper into the inner workings of the system, providing a comprehensive list of currently running processes and their linked user accounts. If you've ever been curious about which program is accessing a specific file or folder, Process Explorer can provide us with that information. So this is what we have as far as our screenshot is concerned. And then you can see right here, so explorer.exe, see if I can zoom in on this. We have explorer.exe, and underneath it, we have the CFF Explorer, Proc XP64, and WordPad that are all under explorer.exe. And so the creators or the authors of it, so Daniel Pistelli, Sysinternals, Microsoft Corporation, as well as the actual command itself, the description of it, the common file format explorer is the CFF Explorer, etc. So this is what the process monitor, or excuse me, process explorer allows us to find. This is the kind of details, the kind of information that it gives us. So from the image above, the CFF Explorer app is open using Process Explorer. Located on the desktop, we identify the process and its parent process. This is usually pretty useful when we want to monitor what other processes are being spawned, such as from a Word document, an LNK file, which stands for link files or desktop shortcuts. So when you create a shortcut or a link file, it's not the actual copy of the process itself. You're literally just creating a file that points to the original copy. So this is also known as a what is it? I completely forget it. We actually talked about it inside the Linux Plus training series as well. It'll come to me. Soft link, there you go. So you have hard links that are actual copies of the item, and then you have soft links that are just pointing to the item, essentially a shortcut. I'm so happy that I remember that. Also, an ISO file, as threat actors typically abuse these types of files as well. So when we want to monitor what other processes are being spawned, they shortcut to it, or even the ISO, which would be the image of that, we can go ahead and find it inside of the Process Explorer. The HXD, for some reason that's really hard for me to say. I have to like pause before I say it. This is a tool for hex editor. So editing files, memory, drives of any capacity can be applied to forensic investigation, data recovery, debugging, and exact manipulation of binary data. Important features include viewing file and memory contents, editing, searching, comparing hex data. And this is what this looks like. So you have the hex data, and then we have the inspectors of it that gives us some kind of information about it. And this is actually beyond my depth as well. I do recognize the hex portion of this. But this portion of the type of data that's being extracted, if I had some time to kind of investigate into it or research it, I would probably figure it out. I'm not going to deny that, but at first glance, it's not something that I recognize because I have not used this specific tool before. So the editor snapshot shows the binary file possiblemedusa.txt. So this is what we have up here. So possiblemedusa.txt is what we have at the top of it. Where is it? Let's go down here. The hex data on the left indicates the file's contents in hexadecimal, and the ASCII interpretation appears on the right. Interestingly, the file starts with 4D5A, which is little endian, indicating it is executable. The data inspector on the right shows you to examine individual bytes by displaying their values in many data types, integers, floats, facilitating a more straightforward data evaluation. So this is, I guess, what we see right here inside the data inspector portion right here. So we have the binary 8-bit, etc., etc. By permitting in-depth examination of a file's unprocessed hexadecimal data, HXD or HexD, I think that's what it is, HexD maybe, facilitates inquiry by identifying file kinds, structures, and possible corruption. Its data inspector feature helps by offering insights to particular byte values. And then we have the CFF Explorer. It has getting comprehensive file information. Investigators can generate file hashes for integrity verification, authenticate the source of file systems, validate their validity by looking for unusual alterations. It's important to know when analyzing malware, since dangerous code may be hidden in altered system files. So when you look at the hash values, right? So when you look at the hash values or the checksums of a file, if even the smallest edit has been done to that file, the hash value changes. So for example, we have the MD5 hash and the SHA-1 hash. If these things change, even if literally one extra dot has been added to the contents of the file, these values change completely. And so if you're keeping track of this, which is usually what happens during some kind of an investigation, there's a chain of custody form. When you have chain of custody forms, inside of those forms, you document the hash values at every exchange. So if I capture the information, I document the hash values. I pass it to the guy in the evidence locker, and he takes it, and then in that interaction, in that exchange, we document the hash values again. And I say, when I transferred it to this person, these were the hash values, and the person signs off, I sign off on it. And then when that person transfers it to the next person, they do the same thing. And if for whatever reason the hash values have been changed, that means either the person in the evidence locker messed with the information, or somebody got into the evidence locker and messed with the information. So therefore, the information has lost its integrity. So this is the crypto miner binary that we see over here. These are the name, type, info size, and then the hash values for it. And then you have any comments. So this looks like Russian, company name, reg edit is the file description, and then we have the copyright again, etc. So in the crypto miner binary, details are displayed in the sample. On September 23, 2024, a portable executable file was generated. This file information can be verified by the hashes. During investigations, this tool aids in confirming file information lookup and locating possible problems. So just the very, very basic overview of what this actually can be done. But in forensic investigations and chain of custody, and then ultimately legal proceedings, this is very, very important information. So just keep that in mind. Wireshark, which is for network analysis, a very powerful tool. It's also open source, and it's very amazing. It doesn't do anything for you, meaning like it doesn't point out anything that would be suspicious for you, but it gives you so much detail and granular information about all of the packets that go in and out of a network that if you know what you're looking for, then you can actually find it because you get all of the details. So you can hunt down dubious connections. I love the word dubious. You can hunt down dubious connections, examine protocols, and spot possible assaults or data exfiltration. In this case, the TLS v12 suggests a secure encrypted connection that can mask harmful activity or safeguard legitimate traffic. And so TLS v12 that we see right here can be something that was resulted from using Google, right? Or using essentially any website that actually has TLS certificates as a part of their encryption, which usually TLS is associated with some kind of high-end encryption that is available for Gmail or Google Drive, or any solid website that actually has really good certificates. So this is the information that we see on the bottom left right here, that we can break each one of these open, and then they go based on the layers of the OSI model. So you have layer 1, you have layer 2, the data link layer, you have layer 3, the network layer, layer 4, the TCP layer, the transmission or the transport layer, excuse me. And then from there, we also have the transport layer security. That is some of the extra details of this specific packet that was chosen. And of course, you have the hexadecimal and ASCII versions of the code as well, or of the packet data as well. So we have the protocol, source, destination, other information. Most packets show that TLS v12 and TCP are being used for encrypted transmission. The raw packet data is shown in ASCII and hexadecimal forms, with a significant chunk encrypted using TLS v12. We can look into the module for Wireshark. Again, all of these things are available on this channel because I have gone into every single one of these videos right here. So you can see there's check marks for all of these. So Wireshark basics, packet operations, traffic analysis, and display filters, capture filters, all of that stuff. All those videos are already on this channel, so check them out. We have PE Studio for static analysis or studying executable file properties without actually running them. This feature is beneficial in several situations. It offers a variety of information about a file without putting users in danger of executing them, which aids in identifying executables that seem suspect or harmful. So you can actually look at the file itself, the source code, and all of its elements without actually running it and determining whether or not it is indeed malicious. So, of course, it has the hash values for it. It has the first bytes hexadecimal. It has the file size, entropy, signature of its entry point file version. It is executable, the CPU architecture, etc. So it has a good amount of information on it, but I'm pretty sure it'll also help you just determine whether or not it is actually malicious. So this is the examination of an executable file, PSExec, which is not in our virtual machine. This is a pure example. A static malware analysis tool. So the file has a dual purpose, legitimate for system administrators, but potentially exploited by hackers for remote access. This is what PSExec can actually do, and we've actually ran a few pentest ethical hacking exercises using PSExec. The file's entropy value of 6.596 indicates a remote chance of packing or encryption, which is typical of dangerous software. Version 2.34 of this 32-bit console-based application allows it to run programs remotely, a feature frequently used to migrate laterally during attacks. And this is assembled using the C++ language. The dual-use nature of PSExec, typically legitimate but suspicious in compromised environments, combined with low to medium indicators that moderately high entropy, makes its presence on a system concerning, especially if remote code execution is not expected. So if you don't expect remote connections to take place or remote code executions to take place, if you see something like this, that is immediately a red flag. And usually IP addresses or machines that are not meant to be connected to remotely have pretty strong safeguards in place. They have firewall rules in place, they have IDS rules in place, and a variety of other safeguards that prevent, and even just the system configuration itself, that prevent remote connections to be established. So if you know for a fact that a computer is not supposed to be connected to remotely, and then you see something like PSExec, that is immediately a red flag. So its use in post-exploitation phases warrants further investigation to determine if it's being misused maliciously. And that is what PSExec is known for. So PSExec, you can just think about it as a remote connection tool for Windows. And if it's being executed on a machine that should not be connected to remotely, that is a red flag. Then we have FLOSS, so Advanced Static Analysis, the Flare Obfuscated String Solver, also known as FLOSS, formerly FireEye Labs Obfuscated String Solver, so FLOSS is probably better. It automatically extracts and de-obfuscates all strings from malware programs like strings.exe. It can enhance the basic static analysis of unknown binaries. Floss also includes more Python scripts in the scripts directory, which can be used to load scripts output into other programs like IdaPro or Binary Ninja. And so this is what a sample command looks like inside of PowerShell. So we have floss, and then we're just running it against the Cobalt Strike executable, which is actually a malicious executable used inside of the Cobalt Strike attacks that happened. And you can learn more about that on the MITRE ATT&CK framework website. Cobalt Strike is one of those famous attacks that took place. And so this is what the results would look like if we ran it. So flare floss results, we have the file path, identified language, expected strings, the static strings, language strings, stack strings, etc. And so there's a good amount of static strings, 189. Then we have the static string that were pulled from it, right? So you can look at a variety of these different things, and at first glance, unless you really know what you're looking for, not much of it stands out. And even for me, a lot of this stuff doesn't stand out. But it was of note enough for Floss to actually extract this information and pull them as the static strings. And so you have this now. This is very interesting, that the long series of A's, and we have set valid or set invalid parameter handler. Now we're actually getting into some interesting strings that are being pulled. Partial loss of significance, total loss of significance, unknown error, runtime failure. I think, no, these are still strings that are actually being pulled. So there you go. So now it's getting very interesting, right? So delete critical selection, enter critical selection, get current process, process ID, thread ID, last error, module handle, proc address, startup info, system time, ticket count, etc. So it seems like there's been a good amount of commandlets that have been run on PowerShell from this specific Cobalt Strike. And then floss static strings, the MSVCRT, dynamic link library, and that's it. So it extracted 189 static strings from the binary, which may contain hard-coded information like the paths, URLs, that are usually for C2 servers, command and control servers, IP addresses, API calls, error messages, registry encryption keys, and configuration data. No decoded strings were identified, suggesting that Floss did not detect or decode dynamically generated or obfuscated strings during this analysis. Malware frequently uses obfuscated strings to conceal its malicious behavior. And we just know, just based on studies that I've done before, that Cobalt Strike is actually a part of a malicious campaign. So just hearing that name, especially in an executable, it raises all kinds of flags, and you really want to proceed with caution. So important to keep that in mind. Now, which tool was formerly known as the Flare Obfuscated String Solver? And that's the one that we just looked at, which is Floss. And which tool offers in-depth insights into the active processes running on your computer? And that is the Process Explorer. By using the Process Explorer tool, under what process can we find the SMSS executable? So now we actually, it seems like we actually have to run it. So let me go ahead and run Process Explorer, which is right there. Can I zoom in on this? I have to manually do it. So that's Process Explorer. So I'm going to run it, and there it is. Let's see if we can drag it onto the center of this thing right here. That is a very weird setup that this looks like. So let's expand that. Excellent. There we go. So we are looking for the parent process for SMSS exe, and it's right here. So SMSS exe, and then we have the system. So we can just type in system. Which powerful Windows tool is designed to help you record issues with your system's apps? So it's designed to help you record issues. So I'm just going to highlight record issues as my little cheat, and let's see if we can find anything. And we do. So Process Monitor, also known as Procmon, is the one that helps you record issues in your computer or with your system's applications. Which tool can be used for static analysis or studying executable file properties without running the files? So Floss was actually one of them. So let's kind of shrink this so we don't have to take so much space. Floss was actually one of them. And then there was PE Studio for static analysis without actually running them. So since we've already used Floss, I'm going to say PE Studio would be that answer. using the tool PE Studio to open the file CryptoMiner in the desktop sample folder, what is the SHA-256 value of the file? So I'm just going to close Process Explorer, and I will do PE Studio here, open that up, and then we're going to look for the CryptoMiner binary. So we can go right here, and there's two ways that we can open a file. And this is pretty standard with all of the software that is installed on Windows machines, really. You can either do File, Open, or you can typically click this piece right here where it says Open File. So that's like a shortcut icon to open a file. So we'll do that, and then we want the CryptoMiner binary. There we go. And so we're just going to open that, and we're looking for the SHA-256 value, which is right here. So let me see if I can copy this. This would be great if I could copy that value. Click on that and copy value. Boom, there you go. So we right clicked on the SHA-256. So let me see if that actually pastes, and it does. Boom, excellent, that worked. Using the tool PE Studio, open the file CryptoMiner bin in the How many functions does it have? So we can go over here and look for the number of functions. So let's see. So the functions portion is still waiting to load. So I wonder if this is something that's going to take a little bit of time for it to process. So I'm gonna just click on it, and I'm gonna wait for it to load. And once it's finished load, oh, boom, right there. So perfect timing. 102 is the number of functions. So there we go. And what tool can generate file hashes for integrity verification, authenticate the source of system files, and validate their validity? So we know that PE Studio can actually look at the file hashes. We literally just did that. But the one that we're looking for is the one that has to do with CFF. And oh, in the next questions, I just knew that CFF was in it. So it's CFF Explorer. So that's the tool. So we're going to do CFF Explorer. And that is the tool. So using the tool CFF Explorer to open the possible Medusa TXT, what is the MD5 of the file? So I'm just going to close this, and I will do CFF Explorer. And from here, we're going to look at the possible Medusa. So again, same thing, right? So if we actually go look at this, you have what? You can do File, Open, or you can click on this and just open a file. And we need the possible Medusa, and there it is. So we're just going to open that one. And the MD5 is right there. So can I highlight any of these? Let's see if I can copy this. Boom, there we go. So we have to double click on it, and it'll highlight it like that. And then you can copy it, come over here, paste it. Excellent. And to open the possible Medusa, then go to the DOS header section. What is the eMagic value of the DOS header section? So this is what we got. And so this is the DOS header right there, the very first item. And we want the eMagic value, which is 5A4D is the value. So 5A4D, like that. And we are officially done with this section. That was good. It was a good amount of information, and we got a chance to actually run this software. Or what is it? What did we run? We ran CFF Explorer, we ran PE Studio, and we ran Process Explorer. So good stuff. I actually really liked that one. So now we're going to analyze malicious files. This is going to be fun. Haha. The first malicious file would be the Windows exe file that was downloaded by a user on 9/24 at 3:43 a.m. Just that time seems very shady. It was flagged as a potential threat. The monitoring team has sent you an email to analyze it, and it is now in the desktop sample folder. So we have the Windows exe that's available. The initial approach is to perform static analysis. So we will be using PE Studio to do it. We're going to open this file with this tool. What information can we see? So we've already done PE Studio, or was it not PE Studio? No, it wasn't. It was the other one. So I'm going to open up PE Studio just in case I need to look at it. The computed MD5 and SHA-1 hashes comparisons were established with the VirusTotal database, which is a massive, very useful database. It's free. You don't need a membership or anything to actually go here. And essentially, when you get to the website, there are 3 different ways that you can search for things. You can drag and drop a file in here, and it'll analyze it for you. You can drag and drop a URL in here, like an IP address or a domain name. If you think somebody shady is trying to hit you up or text you or send you an email, you can always check on that URL here. I come into this website regularly in my everyday life. when I get emails that I'm like, oh, this seems kind of shady, I'll copy the address of the email. I won't open the link, right? I'll copy the address and then I'll come over here and I'll check it. Same thing with hash values. If you can search for a URL, IP address, domain, or hash value, and you will see whether or not that thing is actually shady. So we can have either of these, right? With the databases like VirusTotal, if there are no known detections, there's a greater chance that it's a fresh or undiscovered malware campaign, also known as a 0-day. And although the file claims to be connected to Windows registry, which is regedit, which you can see based on the description, this is likely an attempt to trick people and evade discovery. Legitimate regedit tools are usually found in the Windows System 32 directory rather than the user's download location. So that's interesting. The comments are in Russian. The version etc 50100 new.exe. So this right here, regeditor, this right here in the file's metadata is suspicious, primarily if the user's organization does not operate in a Russian-speaking environment. This could potentially have profound implications for the organization. The absence of a rich header indicates that the file is potentially packed or obfuscated to avoid detection by static analysis. Typical behavior of sophisticated malware that tries to evade detection by altering the critical sections. Function tabs list API calls that the file has imported. So this is also known as the IAT, the import address table. By clicking on the blacklist tab, PE Studio will sort the API by moving all of the blacklisted functions to the top. Interesting. This is useful because it enables us to understand how malware may behave once it compromises a host, and this is what it looks like. So set use shall execute, that is blacklisted right there. Create decryptor could actually be another one as well. So there are important functions. The function use shall execute allows the process to use the operating system's shell to execute other processes, and this is often in malware that spawns additional processes. Then we have CryptoStream, Rigendale managed, cipher mode, and create decryptor. These indicate that the executable uses cryptographic functions, especially Rigendale, which is AESE. And the malware uses cryptography to encrypt communications in files or even implement ransomware functionality. And that's actually that's like a key feature of ransomware, is when they encrypt the files on your computer or on your machine, and they won't give you the decryption key until you pay them. And if it's a really important computer, if it's a very sensitive computer that has a lot of critical data on it that's used for the functions of the business, if they encrypt all of your data, you are essentially screwed. If you have a good backup, if you have recent backups, you should be fine, which is why backups are a big part of disaster recovery. Redundant systems, meaning duplicate systems, are a big part of disaster recovery. But if you don't have a recent backup and something like this happens to you, you are essentially screwed. So that's just kind of like an adjacent tangent that I just went on. So analysis using floss. We're going to go to the directory where the file is, which is this location. Then the prompt for PowerShell, it says it's going to take a while to appear because I think we're just using a weak virtual machine here. We're going to run this command on that executable, and then we're going to output the results into a windows.txt file. And this is what it's going to look like when you actually run it. When you open the file and go to the bottom part of the results, we can see Rigendale managed, cipher mode, create decryptor, CryptoStream mode, all of these things inside of it. These are all familiar because we actually saw them inside of PE Studio. Then we're going to analyze with Process Explorer and Process Monitor. So we're going to analyze the network connectivity to Cobalt Strike located in this. I think this is actually a different portion of the exercise. It may not be for the same thing. So we're going to try to figure out if the file is making any network connectivity to any possible C2 server. Let's get started. Run the Cobalt Strike and open Process Explorer. Let me see if any of these questions, oh, we definitely do have it. Okay. All right. So the first series of questions have to do with the Windows EXE. So I'm going to go through that. Windows EXE. Let's see what functions allow the process to operating system shell to execute other processes, which AVL calls, okay. And then we're going to go into IAMP hash of Cobalt Strike. So we have 4 questions that seem to be relevant to Windows EXE. So first we are going to do all of that stuff. So let me open up the Windows EXE and answer all of those questions, and then we'll move on to the next one, because I don't want to like go back and forth and waste time and energy on all of this stuff. So it says using PE Studio, Open it. What is the entropy value of the file Windows exe? So we have entropy, which is 7.999 right there. So we're going to do that. Boom. And then using PE Studio, open it and go to the manifest administrator section. What is the value of the requested execution level? So manifest administrator, it would not be on the first portion here. It should be on the left side right here. So we are looking for the manifest, which is boom, manifest administrator. And we want the value of the requested execution level. So if I go here, I wonder if I can do Control F to search for something in here. Can I? I can't. Okay, that's fine. So I have to do manifest, or what is it? The requested execution level right here. Requested execution level is require administrator. So that is the value right there. Cool. Which function allows the process to use the operating system's shell to execute other processes? So we're going to go to the functions location, and we want the one that has to do with using the shell to execute the other processes. So let's see what I can find over here. Right there, so use shell execute. This is actually one of the things that also was pointed out in our blacklist portion as well. But so we have use shell execute. That I think that would be the function that we have over here. So let's do use shell execute. Okay, so I'm gonna do set. And then is there, let's see if we can highlight this and copy this. Copy function name. There we go. I think there's probably an underscore. Yeah, there is an underscore there. So set underscore use shell execute is the actual command, or the function, excuse me. And then so what do we have? Which API call starts with R and indicates that the executable uses cryptographic functions. So we now want to go to the API calls and to try to pull data from that. So let me see where I would be able to find that information. And from our notes, we know that the API calls are actually still also under the functions. So it starts with an R and implies that the executable uses cryptographic functions. So I'm going to go over here. I'm going to see if I can organize this alphabetically, and I can. So we're going to go right here. And what do we have here? We have R. Oh, so this is it. The Rigendale manage. That's the one. So copy the function name of Rigendale manage. That should be the one. That is it. Yes, because we were talking about the advanced encryption standard. So now we are going to look at the Cobalt Strike executable. So I can close this for now because I don't think we're going to be using that immediately. So now we're going to analyze the Process Explorer and Process Monitor. So we're going to look at the Cobalt Strike. So first we're going to look at the connectivity to the C2 server. So we're going to run it and open Process Explorer. So it says run the file Cobalt Strike and open Process Explorer on the desktop from the taskbar. You can also search for it in the Windows search bar. If you manually click the binary Explorer exe, would be the parent process, and the Cobalt Strike would be the child process. So let's see if that's indeed the case. So I guess I'm running it. Thankfully, this is inside a controlled environment and it has nothing to do with my machine. So Cobalt Strike, we're just going to double click that to run it. And I got nervous like as soon as they said run it. I'm like, I don't know if I want to do this. Okay, so there is that. And now I need to do Process Explorer. Now Process Explorer is right there. So we'll just open that up. And so what we are looking for is Cobalt Strike in all of these things. So I'm just going to go to filter by name at the very, very top in that search box. And I'm just going to type Cobalt. Let's see if it shows up. We do have Cobalt Strike over here. What do I need? I need to see the properties of this. So I can do properties and it will be able to show me the information about it. So if I do image, let's see if it shows me the parent, and the parent actually is Explorer. So this is not in the way that they instructed us to do it, because they said if you technically have to go browse for it, and you'll see under Explorer that Cobalt Strike would be right there. But I didn't want to browse, so I just literally searched for Cobalt. But technically, if we go over here and if we find Explorer, which is at the very bottom, you can see that Cobalt Strike is also under it. So there's that. This information is crucial. So the goal is to determine whether this process is making any network connectivity and to what destination. The process ID is 4756. And note that the process ID might be different from your machine. Right click on it, select properties, and go to the TCP IP tab. We should be able to determine if the destination, if it connects to, and it's sent. So we're going to right click on Cobalt Strike, go to properties, and let's see what we got here. So first and foremost, I want to find the process ID for this thing, just in case I need to do other information. So what do we have for the information? For TCP IP, I do have some kind of a connection, and it is connecting to a remote host address. The local address is actually connecting to it. That is a no. That's no good. That is no. What else do we have? Let's go to image. There it is. And is there a PID that I can pull over here from this? I can't. So the PID might be probably here. And it's 2024. There you go. So 2024 is under the PID column right there. So 2024 is the PID column. We also do have a remote connection that we just saw under TCP IP. So on another note, when we're doing analysis, it needs to be verified and precise. Therefore, we won't be relying on a single tool. We'll use another tool and stop the process and rerun it. This time we want to use procmon or process monitor. It's also located on the desktop. When we open procmon looking for the binary is challenging, it will list all the active processes. What we're going to do is filter it, and we're going to do Control L to filter it. So I'm going to close this. And I'm going to, oh, you know what? No, I'm supposed to actually kill the process, right? So it says, what is it? It said, therefore, with stop the process. So I can go to the bottom, click on Cobalt Strike, and this X button right here, it kills the process. So we're going to kill that process. Yes. Very good. Process has been killed. Murdered. The process has been murdered. We are going to open up Process Monitor. And then I'm going to go open up that file again, the sample file, and we're going to double click Cobalt Strike again. And so Cobalt Strike is going to run. And so what are we looking for here? Looking for the binary challenging, as it will list all the active processes. What we're going to do is filter it, and we can do Control L, and that would be the filter icon. And using the filter involves several steps. So we want process name contains any value containing to the word or the process. In this case, it would be Cobalt. Click include and then add, and then we should be able to see it. So let's first look at the process monitor here. We do have a bunch of information. Process monitor filter. It actually opened up automatically for me, but I'm guessing this would be the item right here that would actually open that up again. So what we're looking for is, instead of architecture, we're looking for the process name, which is right here. And instead of saying is, we're going to say it contains, and it's going to contain the word Cobalt. And then include, and then add it, and then click apply. Okay. And there we go. So Cobalt Strike, thread exit, TCP disconnect, TCP reconnect, etc. So okay. So now we have some information about Cobalt Strike, and it looks like exactly the same thing that we have over here. Oh, and it's still doing some things here. It looks like it's still doing some things. It's actually still trying to establish its connections, and it's trying to connect to its C2 server, which is what Cobalt Strike does, maybe. It's a TCP connection type of a thing. So, okay, cool. So what is the imp hash of Cobalt Strike exe? So I actually do need to reopen the other one that we had. So let's see, we want the imp hash. I don't know if that was inside of the, maybe it was inside of the Process Explorer. I feel like it's not though. I think we need to use some other tool to be able to find it. So let's see if we can actually do the Process Explorer and see if we can find the imp hash, the IMP hash of Process Explorer inside, of Cobalt Strike inside of Process Explorer. So we're going to go and look at the properties here. I mean, so it's definitely not inside of the Process Explorer. I'm going to go back to my CFF Explorer and see if I can find anything for the executable here, the Windows executable. So we'll open this up and see what we can find. So we do have the MD5 hash. We have the SHA-1 hash. So I'm going to double click this thing right here, and we're going to copy this and see if that's the answer. I think that's the answer, the MD5 hash. No, so it says, please ensure that it follows the standard presented, whatever. I want to say that was it though. The import hash of this. My bad. I looked at the Windows exe. I'm supposed to be looking at the Cobalt Strike exe. That is so my bad. So let's do the Cobalt Strike executable. That was silly. So let's go look at Cobalt Strike. There we go. So the MD5 hash here. Let's double click that. Let's see if that's the answer. No, that's not it either. Okay, so the imp hash, I think it stands for the import hash. So what we're looking for is the import hash value, and I don't know how to pull that information. So I gotta find out how to pull that information, the import hash value of Cobalt Strike. Okay, so it is inside of PE Studio, and it has a value right there, the imp hash right there. That is it. So we are going to copy the value right there, and boom, like that, submit that, boom, excellent. Okay, cool. So what is the defanged IP address to which the process is connecting? And we can find that in the, was it inside the process monitor? Maybe we can actually find it over here as well. Yeah, it is over here. So it's 47.120, 46.210, 47.120, 46.210. So this is where CyberChef comes in. So we need to go to CyberChef and essentially just defang that IP address. So if you know the IP address, you just literally type it in and use the defang recipe, and it'll just defang it for you. So 47.120, 46.210. So I'll do 47.120, 46.210 like that. So you see that, and then from here we'll just go inside of our operations, and I'll do defang, and then you can see that. And so defang IP address, and so we just drag that, drop it right here, and then we have the defanged value right there. And basically all it does is it just puts square brackets around all of the dots, and there you go. You put that and you're good. So what is the destination port number used by Cobalt Strike when connecting to the C2 IP address? And we should be able to also find it over here. If not, we'll be able to find it inside of the other the process explorer, I believe. So if we go right here and see what we can find, so internal 50143, it seems to be hosts NS. So if I click on any of these, maybe we can find it by double clicking and looking at any of these things. The process itself, let's see if we can find it over here. If not, I'm almost fairly certain that it would be inside of the Explorer. So I'm going to close the monitor, and we're going to go look at Process Explorer because we did have it over here. We're going to right click on it. We're going to look at the properties of it, and we're going to go to the TCP IP portion to try to look at the addresses that it's connecting to. And in this particular case, we should be able to expand on this and see what information that we can find. So let me see what I can do here. It actually was not running, so we got to run it one more time. Make sure that Cobalt Strike is actually executing, and then we'll be able to look at the information of it. So let's now open up Process Explorer, and it should be listed right there. Boom, there we go. Okay, cool. So now it's there, and now we can look at that. And you know what? There was an interesting little option here. So when I right click on it, there's a button that says check virus total. So that's cool. So properties, and now we're going to go to TCP IP here. There it is. So let's expand this, and 46.17. Okay, so now I need to make sure that I can find the port it's connecting to. Okay, so if it is not in here, the one place that I know for a fact we can actually find port information is on Wireshark. So that is the one place. I wonder if there is Wireshark that's installed on here. If it's not, we might be able to look for something else. So let me see. Where is it? Is there anything inside of the sample file? Do we have like a PCAP? Oh, we do have. We have a Cobalt Strike PCAP file over here, and it is a Wireshark capture file. So I'm just going to double click this, see if it opens up with Wireshark. It's probably installed already on this machine. I hope it is, and hopefully it'll actually open up in Wireshark. And it does. Look at that. It's opening up the PCAP file inside of Wireshark. Usually it takes a couple of seconds for it to load. You can definitely look at essentially any detail of anything that you want, including the port numbers that it's connecting to. Now, what's easy about this is that there's a display filter portion at the top right here that you just kind of look for IP addresses, all right? So I'm just going to do ip.addr, and then we will do equals equals. So that's how you double check the actual IP address. You do a double equal sign to make sure that it actually means equal. So we'll do 47.120.46.210, and that's going to be the IP address of our C2 server. And then boom, we actually have these things right here. And so you see it right here. So 1010, 155, 140, that's us. The destination is this guy. And then so you have right here. So this is our port, and then that's his port that is connecting to, and you see it right there. And then our port, his port, our port, his port. So 81 is the port number that he's connecting to. And then during the analysis, final question, we found a process called Cobalt Strike. What is the parent process of Cobalt Strike? And it was literally right there. I think it's explorer.exe. Boom, that's it. That is it. We are officially done with all of the tasks inside of this lab. That was fun. I hope you had a good time too. That was pretty cool. So we got a chance to run some pretty cool exercises in today's video, and we got a chance to do some nice investigations as a part of our Flare VM room. So Flare VM is a pretty interesting set of tools that is kind of compiled together for people who want to go into investigations and looking at a variety of either malicious files or processes. And I thought this was great. I think it's a very important series of tools. It's nice that some of these things we have already talked about and we've already used, for example, volatility, for example, Wireshark, and these various tools. So it was nice that a lot of these things we were, or at least some of these things we were already familiar with, especially if you've gone through the CySec 101 playlist with me, through this training series with me. We've gone through several of these tools, so you should be familiar with Wireshark, for example. So that was really nice. It was good to see that we can use it in different contexts. And the other part of it is that we were introduced to a few new tools that I think is going to serve very useful in future exercises. And if you decide to actually go into forensic investigations and digital forensics and those types of areas, these things are going to be very, very useful for you. So this was a very insightful room. This was an insightful exercise, and I hope you actually found some value out of it as well. If you found this video useful and you would like to get more videos like this in the future, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out on this channel. We are pretty much wrapped with the CySec 101 playlist. There's 2 other videos that kind of wrap up this playlist, and it has to do with security principles and just the training that needs to be done for people on your team when it has to do with cybersecurity. But for the most part, we're done with CySec 101 as far as the tools themselves are concerned and all the individual tactics and techniques that we're going to be running. So that is it for this specific video, and for the most part, I would say this playlist, but there's a bunch of other playlists that are in the works. And then there's things like Network Plus that just came out. There's going to be Ethical Hacker and Pentest Plus that's going to come into the future. The immediate future for us holds the AI for Cybersecurity training series that's going to be coming out, which is very, very powerful. So all of these things are in the near future. And if you would like to get notified when those videos come out, make sure that you like, subscribe, and turn on the notification bell. Drop a comment if you have any questions about the exercises that we ran today. If you have any questions in general, or if you just want to say hi, keep in touch with me. But apart from that, I do want to see you in the community. So please make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. I hope I see you in my Discord chats. If not, I hope I see you in the comment section, and that is it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video later.